I hear someone's grandfather clock. That must be Vince's, so we'll go ahead and get started here.
Yep.
Vince, Birgit, and I would like to welcome you to the 36th meeting of the TFRSAC. We've been going on 19 years now. We've only missed one meeting. That was at the start of the pandemic. It's a 2-day meeting. We'll have the same hours both days, 11 o'clock a.m. Eastern to 5 p.m. Eastern. As I said, the times are the same both days. We've been meeting since 2003, and we consider this to be a community of practice, which focuses on sharing best practices and creating new knowledge to advance the wildland management domain of professional practice. We meet twice yearly in the spring and fall to discuss developments and results of ongoing investigations for new and evolving capabilities that support improved fire observation. And our objectives are to demonstrate evolved and evolving technologies for increasing the information content and timeliness of Earth observation data collected for wildfires. We want to make the community aware of new initiatives, solicitations, and collaborative projects, build and mature new relationships and partnerships among the community. Now, obviously, this is our 5th meeting, 4 if you count the ones that we've actually had since the pandemic, and they've all been virtual. Prior to that, we were doing hybrid meetings, and we do miss that personal connections during the meetings, but we found that that there's a lot of engagement that goes on in the chat during these meetings. So, we're making the best of it, and we're hoping that the fall meeting, let's see if that's on the next slide here. Let me introduce Birgit here in just a minute, but we're hoping that the fall meeting will be in Boise in its normally scheduled location, and then we'll go back to having the hybrid meetings. And just recently, we added our new co-coordinator, Birgit Peterson from USGS. She received her PhD in geography from the University of Maryland and has been at the USGS AEROS for the past 15 plus years, supporting various fire science projects, including the land fire program. And I'll let you read the rest of the slide there, but Birgit, if you'd like to turn on your camera for just a minute and say hello to the folks. There you are.
Touchy mic. Hi everyone, thank you. I've participated in this as a speaker and as an audience member for several years. Have really enjoyed it, and it's been a great honor on my part to be asked to represent the USGS as part of this group and as part of the leadership group. So, thank you, Everett, and thank you, Vince, for the warm welcome.
Yeah, and we're really glad to have Birgit. She provides a unique perspective and background that Vince and I don't have. So thank you, Birgit, for taking this on. So this is the basic layout of the sessions. We'll have blocks 1, 2, and 3 today, and we have sort of the normal sequence here. Agency briefings. Later today, we'll go into decision support tools. We'll have a period of open discussion. I really like to carve out some time for the open discussions. Then tomorrow, we'll go into fire behavior, fuel structure and assessment, so forth and so on. Lots of great topics here. And then we'll have the closing session, session 6. The Purdue team will give us an update on their fuel discovery capability, fire hydrology, the fire hydrology connection, which is one that I've been very interested in, the NASA EIS group, the Fire Grand Challenge, the ROGO SATCOM system, breezometer, global wildfire tracker algorithms, and lots of great topics. There's also a number of presentations that did not make it onto the agenda. We just simply ran out of time, and we'll make presentations from those folks available in our online portal where we park the presentations so people can pull them down. There's a couple presentations that don't have actual slide decks. Those are just the ad hoc presentations. Let's see, on to I think the logistics is the next one here. The thing that keeps me awake at night is if my internet should fail for any reason while we're having the meeting here, since I'm hosting the slides and so forth. But I'm hoping that if I get bumped off Teams for any reason that Birgit and Vince can continue and that the meeting doesn't close. I don't recall exactly how Teams works there, but so just be mindful that if I suddenly disappear, it's not something that anybody said and it's not voluntary. So we also want to remind the speakers to be mindful of their allotted speaking times. And if you look on the right-hand column on the agenda, each speaking slot has a time associated with it. Most of the speaking slots are, especially the later ones, are 15 minutes. They're kind of lightning style talks. We ask people to hit the high points and to be mindful of their allotted time. And since we do have a tight agenda, when it gets to, as your time expires, we'll cut over to the next speaker, on the slide deck, which is your signal to wrap up. So we will provide email contacts for the presenters post-meeting, and we ask that you not use these email addresses for solicitations. But one of the things that we really like about this meeting is that we invite vendors to attend, and but we ask that they don't use this forum as a sales opportunity. This is really an information sharing forum. The information that's shared may lead to business opportunities later on, but that's one of the things that we have sort of a hard and fast rule about for the vendors. We'll share the presentations after the meeting, post event. They're actually, most of them are actually posted in the link that's at the bottom of your agenda page. At the very bottom, there's a slides online and then a link, and you can go there and pull some of the presentations. And then we'll share, we also try to share the chat content after the meeting along with the videos for those people that miss the meeting or they miss particular presentations so that they can see those presentations at their leisure. There's some recent and upcoming events. The IGDA Wildfire Management Summit was in April of this year, April 25th and 26th. There's the link there. And we'll make these links available after the meeting. There's the, let's see. Okay, so the International Conference on Fire Behavior and Risk, that's the one that was in Sardinia. I know that Vince attended that meeting earlier this month. Later this month, I guess next week, the International Association of Wildland Fire in Pasadena, 23rd and 27th of May, Association of Fire Ecology, that's going to be in Florence, Italy, the 4th through 7th of October. The 9th International Conference on Forest Fire Research will be in Coimbra, Portugal in November. Pecora, I plan to go to Pecora. That's in October in Denver, and then we'll have our fall TFRSAC meeting. And like I said, I hope that we're able to have a face-to-face meeting. It's really nice to get people together in a room together and be able to have those sidebar conversations and just to see people again. It's really, I think we'll appreciate that more after having gone through two plus years of this. I guess with that, we're a couple minutes ahead of schedule, but Zach, if you'd like to pick up the mic, turn on your video.
Before Zach starts out, I want to add a couple of notes into everybody. We're going to do questions and answers, not verbally with your speakers, but please enter any questions you have for a particular speaker in the chat session, and the session moderator at that point, or block moderator, will ask those questions of the speaker at that time, and hopefully we can get answers to everybody's. If not, add your question to the chat, and as we said, we're going to capture all the chat conversations, and we'll provide those to the speakers. And during our open session time, we may have an opportunity, therefore, to relook at some of the questions that came up that we weren't able to answer during a particular speaker's presentation. So with that, please also keep your mics muted so we don't get any interference from the community for the speakers. And ready to go. Birgit, you want to add anything? I think we're good.
Okay. All right, and with that, we'll turn it over to Zach. If you'd like to turn on your video, and Zach is going to provide the Forest Service Fire and Aviation leadership perspective on technology and future direction. And Zach has been a real key point of contact for me and for the folks in the remote sensing community over the past. I don't remember how long you've been in your positions there, Zach, but it seems like it's been probably 2 years. I've lost track of time during the pandemic, so.
So, good morning. My name is Zach Holder. I'm the Fire Imaging IAA Program Manager for the Forest Service and Operations. I'm hosted at a NIFC, but I'm a Forest Service employee, so I'm in NIFC operations, but even remote from NIFC. So to get to Everett's question there, I was moved into position. I moved into position last August during the middle of PL5 and all that busyness. But I've been in the remote sensing fire intel game for quite a while now, and been a thorn in folks' side along the way, and helping out with projects. So I'm going to start off by just saying, that I will probably give a slightly different perspective than we've historically had in this time slot, because I'm not necessarily in that senior leadership role, but I am in more of the operational role. So what I want to speak to today is really more about the national office level, my program area, working in concert with colleagues that you'll hear from later in this block and today. What we look at in the direct operational support. So when I was thinking about how to really frame this conversation, I started at the basics of know your audience. So the audience here, starting tactical fire, remote sensing advisory. So really been in this new position that's the second person in this position. Evan's started about it. What does it really mean to be tactical, and what does it really mean to integrate those technologies into our operations? So that really has struck a chord with me as I've been out very actively here over the last few months, supporting fires within the Southwest, providing IR daytime intelligence, and also looking at where our gaps are. So really anchoring into that. So really, whenever we look at integrating our technologies, in particular supporting operations, we need to make sure that it's related or constant to a direct action. Meaning that there's a lot of possibilities out there today. All the great technology that could potentially out there, which ones do we want to prioritize on today, and really anchor into decisions that are being made. So it's more of not so much the art of the possible, but what is the art of the possibilities for changing courses of action. So we as the agency have been, or we as firefighters have always been open to embracing technology, but we've also struggled to have that technology become well adapted or readily available. And so what are those type of barriers? So as I'm sitting in this position, looking ahead, what are some things that I can provide to the folks like this group that we're working together to try to find those solutions? So there's a few key considerations that I believe we need to anchor everything into, besides is the technology or the awareness, information, the data that I'm bringing to bear, can it be directly tied to a decision or a set of decision space? And if so, can I deliver that in an intuitive fashion? Or what is the training barriers that need to be provided to an end user, to that lowest level of decision space? What type of training to make that useful, to make that information useful? So before we can overcome that, we need to make sure that we can overcome that before we start going down the road in these large investments. The other side of that is being timely. So can the information be delivered in a time where it's still valid? A lot of the fires that we've been working here, even this year, we've had some additional tools available, but can we get that information to that person in a timely manner to where that decision space is still valid? Should we conduct a burnout here? Is this holding feature still relevant there? Which is becoming more and more challenging with the speed at which fire is growing in our modern climate. that timeliness has become even more important. But getting back is to some other key points here is really some big ones that really stop us, and that's standards and interoperability. So while we may have defined the information needed, a tool to get it there, to deliver it in an interoperable fashion, not everything is going to be a one-stop, one solution, one product provider. We know that. We actually embrace competition and like to have multiple sources and or have platforms coming, in multiple forms and factors, from small UAS to space-based technologies. But is that data that they're delivering being standardized in a fashion that when it is delivered to that lowest level end user, that there is this level of interoperability so that they one, understand what the data is, but two, do not suffer a great basically lacking consistency in what they're getting, or a big chink in the armor, if you will, because the constellation happened to be out of orbit. So now it got substituted with something else, and now they're no longer able to achieve that, to get that data. So I know I'm kind of rambling here, but again, you'll hear some more details coming in, but really just kind of looking at what we're looking for near term. We are looking to expand our incident assessment and awareness capabilities within the agency. A lot of that will focus on, kind of our aerial supervision manned aircraft program that I'm tied into quite closely, as well as UAS continues to evolve and become more adapted into the national airspace. But with those, that's some of the struggles that we are really facing right now before we go out with solicitations or contracts is how do we communicate really what we're looking for? So we're putting a focused effort on that this year to develop those standards. Like I got a comment here. And so kind of closing some of this together is that there is a ton of possibilities out there that, as you'll see talking with some other folks through the day, there's more possibilities than there are people. So within our agency, we're trying to get up to speed on what those possibilities are, but we're also trying to make sure that we're looking down to the scene in action. What are the real problems, tying back into what is the real decision space and what is the real data need? So I would say at this juncture, be patient with us, allow us to organize for success. And once we're able to organize for success within our own ranks and understand how to communicate very precisely, but also with purpose to give you that clarity and brevity in what we're really looking for, I think we have lots of opportunities to expand. So I'm going to flip over to the chat right now. Just sure I covered it, but a little off on my timing here since Vince was closer.
Yeah, the David Green said, can you talk to barriers or sustainability of the technologies by the operational agencies?
So the getting to that is basically, well, I guess that means a lot of different things. So sustainability and the technologies. One is technology is always evolving. So doing large levels of investment, especially within, there's no question about it. The government moves at the speed of government, which can be sometimes very quick, but sometimes very fast, or very slow. But when you get into technology, which is moving faster than I think anybody can, by the time we get something in place and scaled up to where it is in place, it may be great at onesies and twosies, but by the time we get the real interagency scope, by then there's probably already another great thing that's 10 times better. So we're kind of left living in the past consistently. So I think, and Sean Triplett probably, and some other of my folks on the call are probably better to speak to this, but really it's the, how can we get the tools that we're looking for and have them organized in a way that are sustainable, that grows as the technology grows, without having to do a wholesale name investment, if that makes sense. So that we can be as agile as the technology, and as agile as our operational environment is truly starting to become. So I think that's really where we're at right now, is trying to embrace that paradigm shift of, so when we do embrace technology, that it's the same. Along the way as the environment changes. Getting to that question there about the National Guard IA program as a whole, yes, it is separate, but we do partner with our folks within the DoD space. That's thanks, Trevor.
Well, and Zach, I think you brought up a number of really good points here, and I know that folks like you and Sean and other folks out there at NIFC and other folks in fire and aviation are getting hit all the time by, magic solutions and, the latest and greatest thing. And it really does take a while to evaluate capabilities, understand what the benefits of those capabilities are to the existing information needs. And that's one of the reasons why we, working with Evans Quo a number of years ago, we developed the wildfire requirements matrix, which was a way of sort of outlining what the information needed to look like in terms of timeliness and resolution and spectral fidelity and so forth, to help people that are developing capabilities know exactly what the data needs to look like coming into our common operating pictures. And I know that, I'm sorry, go ahead, Zach.
Yeah, so I'll anchor into that, and I was helping Evans with that at the time too. So that is out there, and really we're trying to double down and basically have optimize the inter-branch collaboration within FAM, as well as the interagency collaboration, and really do a hard revision to that. So it is going to take time, but it's ongoing. It's underway right now. But some of those, the matrix as is was a great starting point. And but one of the things that we learned when we go to try to solicit against those, or even set up a collection management tool within on how to order and get the right thing lined up with the right mission, and have that available. It's all an interconnected system. We found that we're going to have to double down a little bit and add some more specificity in there, and also some technical requirements. So that's part of like this year's effort for myself and some of my colleagues. We're gonna be out boots on the ground and really looking to see how this data is used. Again, tying back to tactical. What does that really mean? So we want to make sure that we're seeing that what we think we're delivering is being utilized, and if there's gaps, what are those gaps, and how do we fill those gaps? So we're trying to definitely look forward to the future. We know that there's technology we really want to embrace. However, we want to make sure that we're focusing on the right technology, that we're advertising and communicating the top, not just all the needs, but the top needs that we feel like that we can invest in with clarity, in a prioritized order. So that's a big part of it. Is there's a lot of things that may be shelf ready today, but by the time we try to take that shelf ready item and scale it up on the interagency side, we may have missed an opportunity for something that required a little more polishing, but had an exponentially larger impact on our decision space.
Yeah, I think those are really good points with regard to the requirements matrix. And I'm glad to hear that there's a new version being worked on, because, the first one out of the box was a really, really good effort. It was kind of the first line in the sand there. And I think really focusing on and and highlighting those areas where there are gaps in information, or where the information isn't coming in reliably or fast enough when there's a dynamic incident going on, maybe just getting started. So focusing on those areas where the information requirements aren't being filled consistently or maybe at all. I think that will help.
Yeah, and I think we do glaze over all too often the training. It's one thing to look at the big campaign fire that's got the yurts and uh, the large logistical legs. But in some respects, that's already a big fire, already a big resource suck. But how did it get there, right? It was a fast-moving, chaotic event to start out with in most cases, where people were just really trying to figure out first life and safety. Where can we get an anchor point to maintain life and safety? So in those situations, there weren't these big logistics legs to help develop the communications infrastructure or help provide slick maps to say, okay, here's the road system relative to the fire, so let's use that as a point. So really targeting on this kind of worst case environment would be my counsel to folks thinking about things, but also thinking about not just your particular solution or thought, but the entire system. How do I train that end user? How do I get it from my magic box to a non-magic box to a simple cell phone, and keep it protected and within the grounds of doing government tools, but to those end users in the most expeditious fashion. And I think that looking outward back at the agency, a lot of times I would say that it's probably frustrating to be sitting there and maybe see something that seems so simple. Like, well, why don't you just do that? This thing will give you this. And I will probably tell you from firsthand experience that it's not that we don't value that particular item or widget, but there's probably some barrier along the way that has prohibited us from going down that road. That sometimes, while the simple solutions are always what we want to lean towards, scaling those up are not necessarily always simple tasks. So trying to keep that in mind as well is pretty critical for bringing new capabilities to the table.
Right, and thanks for that, Zach. And I really feel that that this forum that we've established over the years is a way for us to communicate where things are at, where we need to go, and help to illustrate some of the issues that we face as we work to adopt new capabilities and technology. So I think, Zach, we'll go ahead and wrap on your time slot here, and I really appreciate your input. I think it's a really nice way to kick off the meeting here, to kind of lay down some of those sideboards about how we're managing technology intake. And so thanks very much for your time.
I'd like to add to that too, Everett. Zach, I know that you and Sean Triplett have been weighed upon heavily over the last several months with the development of new program initiatives, both within NASA, other federal agencies, and its big push towards supporting the wildfire community, management community, both from the administration, from Congress, and bills that were put before Congress as well. So I know we've relied on you guys heavily, especially you and Sean, to be spokespersons for the needs of the community and the adaptation of technology, Earth observation capabilities, new sensor requirements. And I want to thank you for coming to the forefront in that major push, with being a good spokesman for the partner agencies in verbalizing to our community of technology providers what you really need and your requirements and how they can be met by both federal agency that support research and development operations, as well as the university level research community members and industry that are providing these cutting edge solutions. So thank you, Zach, for always being involved in some of these breakout sessions and discussion sessions and workshops that we've had. Both you and Sean have done a really great job of letting our community know what your needs are and what the barriers are. And we'll be talking about some of those barriers and those workshops that we've discuss those barriers and implementation strategies in the next few speakers over block 1 and block 2. So thanks again, Zach.
Thank you.
And with that, we'll go ahead and turn it over to David Green. And David, I'll go ahead and advance your slides. David is the, I guess you're the director of the wildfire program at NASA. Apologies if I think I actually had it on the previous slide here. The National Wildfire Program Manager.
Okay, well, thank you. And thank you to everyone continuing to organize these TFRSAC meetings and bringing the community together, and your reference to this as a community of practice. I want to follow up on some of the themes that Zach introduced, which is really the idea that there are technology opportunities, there is science to implement, and the challenge of bringing that on to inform decisions, not just in tactical, but across the full suite of the cycle of the fire events. And also the question that I brought up, which is it's not just the on-ramp, but to maintain that and see a cycle of innovation that goes forward and is maintained and fully utilized. So with that, I wanted to bring up this theme of kind of living with fires. And I think that's redefining some of the tactical aspects of what we mean by fires. And also we'll introduce you to the new program and the approach that NASA is taking. So let's go to the next slide. I put this up to really talk about the fact that we are serving society, we're serving decisions, and it's the wildfire in the tactical form, as well as the understanding those cascading impacts. So many of the tools come in to deal with the atmosphere, to deal with the fire behavior, to deal with the decisions for airborne campaigns and understanding the logistics on the ground. And what we've been doing is realizing that that comment is right. There are a lot of different types of information and data. It's being transformed into knowledge and coming into information systems. And those information systems are not single or fully integrated, but they're a combination. And this issue of interoperability is one that, and filling gaps and connections is one that I think our NASA approach, along with others, is moving towards in a more healthy collaborative form. So let's go and see how things are starting to shape up. Next slide, please. So the way NASA looks at what we have on board is a lot of observing capabilities, a lot of data that we collect. We need to transform that into models or simulations or tools that can inform decisions. Sometimes it's in the visual form, sometimes it's in the messaging. But the aspect of transformation of data into practice is one that we take very seriously. The type of information analytics, the GIS or the visualization that can be used for the analysis, and then obviously the infrastructure for that computing, that communications, and that delivery, as Zach indicated, that may go from a satellite or an airborne or a ground station through a variety of partners and vendors to eventually getting in the hands of not just a decision maker, but an actor. And that actor might be in the field, that actor might be in an operations center, that actor may be in a community or a community leadership setting. Let's go to the next slide. So what we're talking about here, and again, I'm really glad that Zach kind of brought this up, is there's a research opportunity. There's the maturing of the research into applications, and then from the applications into operations. What's pictured here are some research partners that we have with the universities that get into quasi-operational environments and eventually get into an operations center right here at the Cal Fire Ops Center. But to do that, we have a series of things that our program and every other program needs to do, but we need to do them together. The outreach and engagement, just like the TFRSAC, and that litany of meetings and conferences that seem to have developed into an entire industry. The community and coalition building, not just bringing them together, but building the strategies of how we will work together. Then the regime studies and the research. The regimes, whether we're dealing in forest lands or grasslands, whether we're dealing in the Arctic or the lower states, or international partnerships, we need to understand what those regimes are, the nature of the hazard and the risk, assessing what that vulnerability and exposure is in combination to different fire, smoke, or patterns relative to property, relative to health, relative to a number of stakeholders. That includes then this analytics and the simulation of not only what is happening, but what may happen and what may happen next. In order to move it forward in transition, we are supporting and partnering with others on test beds, pilot projects, reference data sets so that we can start to have standards and things to intercompare, moving to demonstrate what ensemble approaches are of not just our individual tools or individual models, but what do they mean collectively? And then the transitioning into operations, which does include the capacity development, the training, and even understanding that training modules need to be short, tight, and really deliver the information that operators and partners need. And I should mention the feedback that needs to go back to the research and the technology innovators so they can go back, make corrections, plan for the next generation. Next slide, please. So within NASA, we've taken a relatively new approach. All the Science Mission Directorate, Earth Science, across different disciplines are coming together, as well as the A in NASA, the aeronautics component, and the science technology mission, which includes such things as sponsoring grand challenges that you've heard about us going to the moon. Well, now we're looking at the grand challenges and competitions we need to deal with the issues here on Earth, as well as the business partnerships and supporting. So research, from research to applications, technology to flight, to the coordination, common operating procedures for our aeronautics and airspace, to the innovation that needs to be done today as well as long-term into the future. Next slide, please. The other thing I want to mention, and I know this is a tactical component, but the NASA approach is looking pre-fire, post-fire, and active fire. And we're looking at the bridges that need to be taken into consideration in the pre-fire regime that can set up for successes in the tactical phase and the tactical evolution of the fires that are going to inform the subsequent actions in post-fire. Obviously, NASA, as a science and technology developer and implementer, is not the operator, but we work in support and enabling, and that's why that feedback is so important. But we're also looking at where tactical fits and perhaps is changing in scope as we think about this living with fire situation. Next slide, please. Now, there's clearly a lot of satellite assets up there. I'll just remind you that you should be thinking of these as not just taking a picture of the Earth, but these are the Swiss Army knife of answering particular questions. Some of those are looking at vegetation and soil moisture, which are important to fuels. Others are looking at damage and change, looking through clouds, looking through smoke to see what's happening to property, infrastructure, the wildland interfaces. But there are a host of instruments that NASA has, and particularly important is the fact that this data is free and openly available. Similarly, Europeans and others are making their satellite data available, and increasingly many other partners, ground stations, airborne systems, and then the partnerships with the private sector, which are perhaps of a commercial nature, but are there in available for research and development, and then when proven valid, are available for our new operating practices and policies. Those test beds and pilots and demonstrations are what are going on in our collaborative mode to see where we can evaluate the quality of that information and how it can be integrated together. Next slide, please. Now, this slide just represents the fact that we are looking across the pre-fire, active fire, and post-fire. Different tools are used through the different cycles, and we need to understand that complicated dance of instruments and assets, and that's why that concept of operations is being reviewed, and the collaboration of not just what tools and what assets, but when and where do they have to interact together? Next slide, please. Now, one of the things that we've been piloting is an Earth information system appropriate for wildfires. I'll mention that there is actually a complementary one on water resources and flooding, which is going to be also very important to the wildfire community, but is looking at the types of tools, analysis, and partnerships for the risk modeling, real-time event tracking and analysis, the fire spread and fire behavior, the emissions into the air, and the post-fire debris, landslides, and mud flows that may be subsequent concerns. Next slide, please. This is an example of one area of results that we've been looking at and hearing feedback from communities is in the fuel structure and fuel moisture opportunities. Partnering across NASA and with key agencies, new assets as well as traditional ones, to look at the structures, the moisture, the pre and post-fire assessments of the consumption, health, and quality. Can we make progress in diurnal campaigns and long-term airborne assets for monitoring and surveillance? These are some of the things that are on our plate for our consideration, but also for everyone here to give us feedback on and partner where relevant and possible. Next slide, please. So here's targets of opportunity. Looking at the composition and structure today of the moisture of fuels and the distribution of them relative to areas of concern, such as a residential area. What's our current data and mapping structures that we can assess, and what is that future state of what we could do with our airborne assets, our new sensors, the combination of tools to actually improve the accuracy. And so we're setting essentially a 5-year timeline to get from new prototypes and pilots into demonstration and evaluation, with the idea that this future state is perhaps the first phase 5 years away. Let's continue with a few other examples. Next slide, please. Our program in FireSense is also looking at technology, detection capabilities, and in particular, the transformation of single sensors into networks of smart sensors, how those smart sensors and data suites come together in big data problems that can be analyzed only through cloud processes, digital twin analysis. So going from current data to look at fire sheds and watersheds, the interactions in different environments, from a local scale, global scale, and back to our local communities, and the future capabilities of longer term surveillance and more use of different assets. Next slide, please. The fire weather is one that we've heard a lot of key partnerships with. And again, areas that we are looking at for our current investments, test beds of new capabilities, talking to NOAA about what they're doing in wildfire, but also many in the private sector, across different communities, looking at the different attributes that could be important to the ideas of prescribed fire versus the active fire and how we should think of those and their interactions. Not only the technical piece, but understanding who and where the communities are that are impacted. The environmental justice components, that not every community will be impacted the same way. Next slide, please. We have traditionally had airborne campaigns, but now doing them in a more integrated fashion across multiple assets and with multiple partners. We're in the process right now of designing and looking forward to additional campaigns in coming years, as well as the new tools that are coming on board, and therefore a perfectly ideal time to not only design the coordinated airspace, but to think about the types of analyses, comparisons, collaborations, and cooperation that needs to go on between all manners of mobile observation to again transform that into information that we can take action on. Next slide, please. The attributes of fire behavior are one that we've also been hearing back in our outreach to partners, whether at NIFC or private sector, to explore where the advances are that can actually see these explosive natures of different types of fire behavior than perhaps we have seen in certain locations in the past, or fire behavior that is moving much more rapidly, or more frequently ignitions in places that we hadn't anticipated before. Next slide, please. Getting close to the end here. Fire emissions, I mentioned before, there's quite a bit of interest now bringing different communities together, not only the fire emissions from the point of view of can we monitor them, understand them, but also understand the impacts. So the air quality concerns and the health interruptions and the variety of tools that are needed on the ground, on platforms, in the air, and from satellite, combined to understand also that the nature of the materials that actually burn and combust in a fire can be of a toxic nature or a material of concern. So therefore, we're also working with not just the tactical safety of the communities, but the tactical safety of our people in the situations, and therefore understanding how to create a much more appropriate environment to either work directly in the field or to inform remotely. Next slide, please. Now, clearly, there's development of what we call trusted tools, FIRMS being an information system that has been around for a while and continues to be improved. Recent collaborations between US and Canada, certainly the fires and the information don't know where the border is, but our tools need to cover and expand on all of them. These types of tools, trusted by the research and science community, are increasingly trusted and utilized and need to be transformed into the appropriate tools for our operators and tactical centers. We're seeing quite a few opportunities there with the new capabilities coming on board. And one of the things we're trying to also see is that this is not the only trusted tool, and these tools need to be connected with others. Next slide, please. To that effect, an example where NASA has a disasters mapping portal. It uses an enterprise approach to GIS to develop a number of capabilities for 2D, 3D simulations, for models, for looking at drought and water and airborne and the relationship to population centers and the vicinity and the assets that can be brought into these fields from drones or airborne assets of different types. Let's go to the next slide, please. Now, because there is so much going on in this kind of geospatial analytics world, we're actually encouraging and creating something called the Center for Environmental Collaboration. Working with Esri and Google and various others, we need to have an experimental sandbox where we can bring our information together. We're calling this the Keck Ash Hub, and we will be releasing the first version and engaging with the community next week at the International Fire Meeting in Pasadena. Again, the intent here is a collaborative space, a safe space, a pre-competitive space, a place where we can evaluate, combine, test, and analyze how our information can come together. Next slide, please. Over the next few years, NASA, in partnership with many others, are going to see a shift from just a system of observations, but back to the idea that the Earth is the system, not the observations. So looking at all of these new assets coming on board for clouds and aerosols, for surface and change will be something that we need to prepare for. There are early adopter programs. There are new and preliminary data sets and synthetic data sets that we need to be exploring now, because we know over the next 5-10 years, there are going to be incredible enhancements of the data available, but we have to be turning that into knowledge now, not waiting until it's already launched. Next slide, please. Clearly, no single agency has a role. Here, the typical diagram of every agency, but sincerely, it really is a new environment. NASA is bringing all of its groups and programs together in a way it never has before. And I really want to thank all my partners across the different federal agencies, even the different NASA centers, because we are in a new realm of moving to this living with fires. I think redefining what tactical means, and it's going to have new players with new maturities of experience, and I think new levels of understanding of who we're going to work with, the next generation of early career I recognize a few of our interns and our grad students who are really interested in this more collaborative way we move forward. And I'm really glad that we've started off TFRSAC this year with this idea of what is the evolution, what's the new ways that we might think. Let me conclude the next slide. I think it's just points of contact. The Wildfire Sense is a management team across NASA. Mike Fukowski for Earth, Terrestrial, Ecological. Barry Leffer, Air and Atmosphere. The technology areas, Mike Seablum and myself in applications. We're the 4 key points of contact. That doesn't mean we're the only programs, but we are the 4 that are leading in this fire sense approach. I hope that's really helpful to understand who to work with, our strategy, and hopefully it'll be echoed in some of the other talks throughout the fire sense, throughout the TFRSAC discussions today and tomorrow.
Well, thank you, David. There was 2 comments, one from Paul Stebline. NASA has great data and technology resources. How do you propose we start looking at IT strategies or enterprise architecture across major providers to make it easier to find and use data, align with HPC capability, and to apply with stakeholders?
Well, there's a lot there. And as I said, we are specifically developing and investing in projects and pilots that really are looking at these architectures and investing in directing the need to look precisely at those types of problems that you're mentioning, Paul. There are platforms that are going to be of particularly cloud nature, but also still a number that are of a hybrid combination of systems. And so we are looking at and co-investing in some of these information systems. And as we were also discussing, the importance of having a common sets of data and reference data systems so that we can have true intercomparisons, and also giving ourselves enough time in the investments, I should say. None of these are going to happen overnight. And that's why I've also said we're developing a kind of a 5-year roadmap to do prototype of these systems, moving to initial integrated operational capability across the different systems, with the goal that 5 years from now, we'll be at kind of this next threshold of kind of a thriving state of systems of systems. I hope that's helpful.
Yeah, that was good, David. I'm going to go with one more question, and then in the interest of time, I'll leave the other 2 in the chat there. This one is from Don. I see SBIRs as a vehicle to rapidly identify unready research and systems to operations, weather instrumented drones for data collection around fires, UTM systems for deployment to manage drone and manage air traffic safety. These are quick ways to fill gaps in a complex system.
So SBIRs are definitely part of the structure at NASA and at other agencies. As I mentioned, 3 different directorates coming together. So Earth Science, Aeronautics, and the Science and Technology Mission. That includes, there's already been 2 calls, I believe, this year for SBIRs related to wildfire. And we're actually crafting the language and strategy for an SBIR call for 2023. So we definitely, it is part of the integrated approach.
Thank you, David. And as a panel member on SBIRs, I'm seeing a lot of wildfire-related technology proposals come through. So
one other thing I might mention there, just closing, is there are so many. You're absolutely right. And one of the things has been the concern that there's almost too many solutions coming out of the woodwork. So one of the things that we're also planning to do on the technology side is perhaps sometime in the fall or early spring is a technology showcase that can actually bring a lot of these forward, because many of the SBIRs are on a very similar theme. It's very hard to judge when there's just so many solutions coming forward. So we think that one of the things we're going to need to do, and we certainly like to do it with TFRSAC and its partners, is this idea that we need to do some kind of showcase of the solutions that are bubbling up.
That's exactly right, David. And thank you for your time and your presentation. That was really great. Nice follow on to Zach's presentation there. And with that, I think we'll go ahead to the next presentation. I'm going to turn it over to Birgit for the introductions here.
And David, you might want to check out the meeting chat, and there's a couple other questions in there that you might respond to in the chat session, so that those questions are answered by those attendees. Thanks.
And with that, I would like to welcome Paul Stebline, our USGS Fire Science Coordinator, to give our next talk. He will be providing an update on the U.S. Geological Survey and their work in wildland fire science. And I've had the pleasure of working with Paul now for the last few years, and he's been doing a lot of work to get integrated science in that notion across the board and into USGS and beyond. So with that, welcome, Paul.
Thank you so much. It's a pleasure to be here, and especially enjoy the opportunity to present with colleagues like David and Zach earlier. And I think the notion of the integrated science is a key part that you'll see through here. The other part is that you'll see peppered through this is the notion of partnerships, collaboration. David emphasized that quite well. And I will post something to the chat later. I've been involved with ICAM's Interagency Coalition for Advancing Meteorological Services, which has had a interagency charge of helping to focus on science needed, earth observations, and other information needed to support fire. There's a workshop coming up on June 2nd, so I'll include some contact information for that. So I've reported a couple of times to this group on the development of our strategic plan and our implementation of it. And so I've got a couple of links here right at the beginning that gives access to our fact sheet, the strategic plan, and some information. The next slide. And in this strategic plan, which I'm so glad it is now has been released for about a year, it really captures a big effort, including a lot of stakeholders, but a big effort to identify 4 priorities: advanced, integrated, actionable fire science that meets the need, listening to and working with stakeholders, and that's not just up front, but all the way through the whole science cycle of identifying the need, designing and delivering results, ensuring the public knows what we do, where we get the results, and what it means. So this translation about something that's so important to the public, like fire, and then enhancing collaboration within USGS, but also with partners like NASA and Forest Service and all the others that are represented here today. Next slide. So what I plan to do is touch on how we're implementing some aspects of this. One of the key ones is this innovation landscape, or a landscape science support type structure. And we'll be setting up a pilot in the Southwest, but in specific to support the bipartisan infrastructure law. There is really an unprecedented amount of resources in that law, that act that is supporting to deal with wildland fire risk challenges. And so we have been working with the Office of Wildland Fire and other DOI agencies to find the best science support. And I come at this having been a line officer, managed a 1 million acre refuge complex as well as other refuges. And the challenge really was getting, finding the science support that I needed, the tools and the data. It's unusual to have all the staffing that you need that has all that expertise. And so when I was at Sheldon Hart Refuge, I linked in with quite a few scientists at OSU, USGS, and other places. And that's hard to do in a consistent way across the United States for DOI lands or other land management agencies. And so this idea is that you can have a local team of expertise and attention, a landscape team, that's able to identify what the values are, what's important to each of those different refuges, public lands, or parks, or tribes, and identify what is the value that's at risk from fire, and how to apply these tools to best anticipate the longer term future, but also to implement the program today, do monitoring or whatever else. And so we have a local landscape team. We're able to link in to modeling support or scientific expertise, and to tap into some of the rich and big data sets out there, or develop locally as needed. And so the idea is that we can help foster decisions across landscapes, as well as meeting the local need and a better ability to scale up to national scope. So often we have to report regionally or by state or national on things where there is such a big investment as in fire these days. So this, again, it's a parallel in some ways to what Forest Service has done. They have, they do excellent work in providing support and shared stewardships, pods, and some of the other activities. And the idea is we would be able to integrate and work with them on this to meet DOI land needs. Next slide. So a key part of that is evaluating the risk, and many of the DOI lands actually are not forested landscapes. They're sagebrush steppe or southwestern deserts or grasslands or tundra or swamps or other types. And so we need to make sure that the models can work well on those landscapes, and the risk models represent what the values and those hazards are, and associated with those fuel types. But a key part of any risk reduction effort and investment is you have to be able to assess the effectiveness of those. And so part of this scope of this is to actually be able to adapt them and apply locally while meeting the mission needs for those particular land areas. Next slide. Part of that is having an effective monitoring and evaluation approach. And we've been piloting an effort down at, in the southern border, Buenos Aires Refuge, using TLS, terrestrial laser scanner systems, and aerial LiDAR and other kinds of data to update the fuel models, and to be able to use advanced modeling capabilities such as quick fire or other types. And so we've been developing this protocol at a parallel way. I think the next slide we can go to. Parallel way is with Fish and Wildlife Service and Forest Service have been developing a TLS system based on the Leica BLK 360, and developing the code using machine learning and other capabilities to characterize that data and to use that for whether it's timber inventories or what changes took place in the structure of the vegetation that can be incorporated into these advanced coupled fire atmospheric models. And so this is an example of results from the sagebrush steppe, where because of the sparse vegetation, traditional fire behavior models do not work as well. And so we're finding good results using quick fire, using 3D fuels based on TLS. And you can see the emergent shrubs, the sagebrush bushes, and then the surrounding sparse vegetation in this graphic. So this is a big partnership effort, and USGS is working with Fish and Wildlife Service to set up a system at Eros to store the data, to run the scripts, to convert the data into resulting information. And now we're working in establishing partnerships with not just Fish and Wildlife Service or Forest Service, which has contributed a tremendous amount to the development of this capability, but also now with the Bureau of Indian Affairs, SWRI, Park Service, BLM, to try piloting these protocols out on these land unit areas. And we think this is going to make a big difference. It is also needs to be done with aerial LiDAR, like 3DEP or something equivalent to that, maybe higher densities of data, but to be able to then take this ground-based approach and scale it out so that we can develop new 3D vegetation information that allows us to evaluate the risk models over the broad landscape rather than just at the local land units. And Forest Service does have an excellent product that they've been developing called Fast Fuels that automates that using existing data such as land fire. Next slide. Integrated science has been a real focus of this. There's a number of factors that have been identified as being critical to the patterns of change that we've seen in fires, the changing regimes, and that is invasive species or climate change or human activity and ignitions or insects and disease or fuel growth. So all of these factors are really important, but they're dynamic and they're interacting, which makes it a lot more complicated. The other is trying to integrate across, for example, fire phases. And so traditionally, USGS has come in to do debris flow assessments after the fire. So developing burn severity maps and then use that to predict debris flow or changes in water quality and quantity, or to be used to inform bear plans. So what we've tried to do is then couple fire behavior models with to predict burn severity so that we can link up then these post-fire models to predict ahead of time what is the risk of these post-fire hazards and their potential to affect things that are important to society. And so we've been doing a project for the last year and a half, and finding actually quite good results using a AI/ML approach to predict burn severity. So the example shown here is Grizzly Creek, and we were able to predict burn severity with and highlighted the same area where the debris flow event took place that crossed I-70. So the notion is that we would then look at better, instead of ML, use process models like QuickFire or FireTech, that we could then start looking at other driving factors, linking models to it, such as climate change, so that we can look at what is the potential change in post-fire hazards down the road. Also, that we can use the things that we learn from this to build lower resolution, but very broad risk maps to identify what are the basins that are at risk across the West due to fire and antecedent conditions. So anyways, it's an area of work that we are continuing to work on. We've done some in Colorado and now looking at establishing similar studies and modeling in California and Washington declared disasters. Next slide. A key part of this, though, is the models themselves and the experts that are using them. We've been a partner with the Wi-Fire Commons, which is a coalition of Los Alamos National Labs, UC San Diego, Forest Service, Tall Timbers Research Station, and others. And one of the things that we found is a common need is a more efficient way to be able to take care of the models themselves, to curate them, the code, make it easier to find. We are not the fire behavior experts, although we do have some expertise in USGS. We see it at Forest Service or some universities or other places. And so partnering and making it easier to partner across organizations is another important aspect of our finding greater efficiency and capability. And so what we've been advocating is establishing an interagency cooperative for fire and ecological modeling. And this is supported by scientists in all the agencies that I've mentioned or organizations. And we actually have it in our 23 President's budget request to fund this kind of an enterprise, to be able to have the computing resources and support to pull the data and the models together to make it more readily available to those that want to participate and advance the use of the models, the improvement of the models, or the application for management purposes. Next slide. And one aspect of that is having the right data to apply to the models or to improve the models or to evaluate those. And this is something that at a prior TFRSAC meeting I mentioned, also proposed to JFSP, the Joint Fire Science Program. But we're seeing unusual conditions out there with some of these big fires, really damaging fires. And we need to be able to make it easier to pull the data, assemble the data from these, to take the evaluation, the models from the controlled situations, such as the instrumented prescribed burns that CERTUP ESTCP is doing, as well as RX Cadre is another prior one, and FASME, some of the work that they've done, but take it to actually the wildfires themselves. It is very time consuming, and we've done this on a few, time consuming to develop those data sets. And so we should be able to assemble a coalition of agencies or scientists to put the research grade data sets together, information before the fire, during, and after, so we can really make some advance on some of the research, model development and application, and to make it more cost efficient to be able to do this, rather than each one trying to do that for the Dixie Fire. So key part of this, though, is also having the right kind of enterprise architecture so that people can find it and use it and apply it, and the curation that goes with keeping the data available in the long term. Next slide. I think this is my last one. And again, our vision is having integrated science, having excellent partnerships, collaboration with scientists, but also with the application area with the managers and practitioners, that it really is dependent upon effective and efficient and productive modeling, not just fire, but all the other related areas of it. And that we have the right data available, critical data, on a good designed, a well-designed enterprise architecture, so it's well curated, secure, accessible, and efficient. That's it. I'm glad to address any questions.
Thank you, Paul. That was really good. Let's see. There's a number of things in the chat here. I'm going to switch back to my headset because I'm getting a feedback here. But have you looked into integrating synthetic aperture radar?
We've had some discussion. Birgit might be able to respond to that as well. It certainly is a source of point cloud. Some of the discussion we've been having is, how would you use different source point cloud data to try and characterize 3D? I think that probably is certainly a platform that's available on satellites, and so for updating 3D, of course, the resolutions might be very effective at having the time frequency for updating 3D data sets. It's not just doing it the first time. It's, for fire and fuel treatments, you need to have regularly updated data, and so that's a big question, a big issue. SAR may be a reasonable answer for that.
There's also a question from Ed Freeborn. Can outreach to local communities and their GIS programs and existing programs be used to address the data problem?
I think first of all, I think there's a lot of different kinds of data problems. Everything from the end user having the right technology to access it to having the expertise to be able to apply it. I think local FireWise programs, local universities and organizations are all a critical part of the stakeholders that use the information and probably contribute very relevant, very important information. I think the other part of it, and I didn't mention it before, and I'm going to segue just a tiny bit, and that is that I think the key difference in the quickly changing landscapes, quickly changing experiments is this landscape approach fits in very well with using an experimental design with implementation with land managers and communities for that matter, so that we treat each of those efforts as an experiment to test out the models, test out the information and data, and improve it and adapt as we have to the changing world.
Hey, Paul. Yeah, this is Ed. Yeah, I was just kind of curious because like Firewise wasn't in your chart there, but yeah, if you include them in there, then the problem is currency and maintaining it, right?
Yeah.
So those existing programs already have a vested interest in that. So it's good to hear that you're already going to be reaching out to them. That's great. Thank you.
Yeah. Let me just say that boundary spanning organizations like Firewise, the Fire Science Exchange Network of JF Joint Fire Science Program are critical, I think, for bringing people together, for sharing information and developing new information. So good point. Thank you.
Copy. Thanks.
And with that, I think I'm going to go ahead and thanks very much, Paul. That was a really great presentation. I'm going to go ahead and turn to our next presentation, which is Carol Vadnais. Carolyn, can you give us a sound check?
Yeah, this is Carolyn. Can you hear me?
Yes, I can, and I'll go ahead and advance your slides. Carolyn is she's a contractor with the USGS National Land Imaging Program, and she's been a frequent contributor and participant in the TFRSAC over the years. So it's all yours, Carolyn.
All right, thanks, Everett. Yeah, we introduced the idea of this rapid assessment at a previous TFRSAC meeting, which we did conclude in March. And so the idea today is to present the outcomes of that assessment. Next slide. Yeah, the assessment team task was to conduct a rapid assessment of observation and information shortfalls related to wildland fire that could result in specific actionable recommendations to support future agency planning and budget development. Next slide. Our approach focused on the collection and synthesis of information provided by subject matter experts, review of publications and reports, and attendance at meetings and workshops held during the assessment period. The team looked for existing ideas and initiatives which could provide near-term value to the community if funded. Next slide. All phases of fire were considered, from mitigation and adaptation to fire prediction, detection and monitoring, active and post-fire assessment, and rehabilitation and restoration of the land post-fire. Next slide. The assessment team interviewed 99 subject matter experts during the assessment period. I'd like to thank a lot of the people who I see on the phone and even presenting today for contributing to this. The general distribution of SMEs by organization and fire phase are shown here. Next slide. Now let's turn to the recommendations. Next slide. The next 3 slides summarize the 21 recommendations from the assessment. These are not in any sort of priority order. I'll provide some more detail about these in subsequent slides, but here we've simply categorized them by recommendation type. So whether they address observation gaps, are needed to provide data continuity, point to product enhancements, systems development, address programmatic shortfalls, address research needs, or require new collaborations. While not definitive, we've also indicated the general phases of fire each recommendation helps to address, and the organization is likely to have a role in implementing the recommendations. Those that are bolded in the first column, which includes all of them on this first slide, are those that aligned most closely with the original scope of our assessment, focusing on observation or data gaps. Finally, the small bunch of grapes to the left of the recommendations indicate our initial assessment of those that could be considered low-hanging fruit. And by that, we meant that they have a relatively clear path to implementation and could provide tangible near-term benefits to the stakeholders. Next slide. This is slide 2 of the recommendations. Next slide. And here is slide 3. Now I'm going to quickly go through a subset of these. I'm going to go pretty fast through the material. There is a lot more detailed information to include references and supporting information, both in the notes pages of this slide deck and also a companion PDF file which we produced, which has a summary of all the information from the assessment. Next slide. The remote automated weather stations, or RAWs, are important surface observing systems cited specifically to provide observations needed to support wildfires. 2,200 of these are federal, but ownership is distributed across the land management agencies. Less than 5% of these systems currently have soil moisture sensors, and less than 2% belonging to the Forest Service measure soil moisture. Soil moisture is important in assessing wildfire risks and post-fire hazards, as well as in monitoring climate change. The Forest Service currently has an unfunded proposal to add soil moisture and temperature to all Forest Service ROS stations. The recommendation is to fund the Forest Service proposal and to consider extending this initiative to other ROS owning agencies. Next slide. A key gap in atmospheric measurements is data to characterize the planetary boundary layer. Boundary layer data are needed to understand, model, and predict fire and smoke behavior and the subsequent impacts to air quality. NOAA currently has 2 activities that will help fill this gap. First is an initiative to acquire 4 fixed and 2 mobile surface-based profilers. NOAA is working with NIFC on siting for the fixed profilers and will deploy the others as needed to support wildfires. The infrastructure bill provided initial funding for this, but funds beyond FY22 are needed for operations and maintenance and to add additional locations. At the same time, NOAA's Automated Surface Observing System Service Life Extension Program will make boundary layered profile data available from all 900 plus ASOS locations nationwide. Additional funding will accelerate this program, making the data available sooner. Next slide. The Canadian government plans to launch a Pathfinder mission called TFRSAC, which will provide data on active fires, smoke, and post-fire impacts in the early evening, which is a unique overflight time not currently available from any other satellite. The data from this mission will be freely and openly available, but funding is needed to explore the feasibility of using existing NOAA and NASA real-time ground station networks to downlink and distribute the data. Next slide. While there's a growing number of government contracts being put in place that will provide access to different types of commercial imagery, licensing restrictions limit availability of that data to some agencies and sets of users that have operationally focused missions. Additionally, some contracts restrict the availability of the data until after a certain wait period, which limits usefulness for things like active fires and post-fire hazards assessment. The adequacy of current contracts to support the wildfire community needs to be evaluated, and the gaps need to be addressed either through license uplifts or new contracts. Next slide. The 3D Elevation Program, or 3DEP, managed by USGS's National Geospatial Program, is responsible for managing the collection of LiDAR data for the US and territories. LiDAR data are integral to activities across all phases of fire. These are essential to quantify fire fuels, prioritize fuel treatments, increase the accuracy of fire behavior models, guide post-fire hazards assessment, and improve carbon emissions estimates. At present, 16% of the nation does not have 3DEP LiDAR elevation and point cloud data available, with the largest gaps in the western US where the fire danger is most extreme. Recommend funding to complete national coverage of the 3DEP LiDAR data. Beyond that, funding is needed to ensure these data continue to be updated. The 3D National Elevation Requirements and Benefits Study will be completed in 2022 and will include a plan for data refresh, which can guide refresh execution. Next slide. Since October 2020, the Firefly program has provided fire location data nationwide every 10 to 15 minutes through National Guard units in California and Colorado. The availability of this data in a product called FireGuard has been a game changer for operational fire detection and monitoring. The program is a result of work done through the National Civil Applications Center by the Civil Applications Committee Thermal Working Group, leveraging data available from the DoD and intelligence community. Accurate and timely fire detection and location monitoring enable decision-making, deployment of resources, and ultimately can save lives and property. Firefly is the only source of fire location data available at high temporal resolution to the community. While the data provided by the Firefly program has been a huge step forward, there's still work to be done to improve the accuracy, timeliness, and robustness of the overall system capability. The CAC Thermal Working Group developed recommendations last fall to address the shortcomings of the current system. These need to be resourced and implemented. Next slide. Today, fire perimeters are updated once a day by NIROPS or other airborne assets. The Firefly program I highlighted in the previous slide is an important set of information, but doesn't deliver the accurate high-resolution fire perimeter information needed for tactical decision-making or model initialization. Accurate fire perimeters are critical to firefighter safety, movement of firefighting resources, and situational awareness. Additionally, geospatially accurate fire ignition and perimeter information is vital to the accuracy of fire behavior and spread models. This recommendation is to explore additional sources of thermal data at high spatial resolutions that could be scalable depending on the need and provide either continuous or sub-hourly updated perimeter maps and fire intensity information. This could be through additions or enhancements to the current government-owned fleet of aircraft, leveraging high altitude, long endurance platforms, or investigating the emerging set of space-based constellations that will provide thermal data at high spatial and temporal resolution. Next slide. The Terra satellite is reaching end of life, and the MODIS sensor on that platform is important for fire detection, burn area mapping, and for monitoring post-fire recovery. 2 decades of MODIS data are also important to the broader science community for its contributions to essential climate data records. UMETSAT's METOP AVHRR and METOP second generation instrument METIMAGE, along with the Sentinel-3 SLSTR sensor, provide coverage in the morning orbit like Terra and MODIS at similar spatial resolution. To fill the coming gap in the morning fire detection and to provide long-term continuity of the MODIS data record, NASA should continue to operate the Terra platform as long as possible to deliver MODIS data to the fire community. This will maximize the value of the existing platform for those who rely on MODIS fire data today and enable new science from observations of the diurnal cycle of fire activity as the overpass time shifts earlier. At the same time, NASA should work to develop the algorithms needed to provide continuity in the data and products for active fire and burned area between MODIS and the METOP and/or Sentinel-3 instruments. Next slide. Landfire is a partnership among the wildland fire management programs of DOI, the Forest Service, and the Nature Conservancy. The program produces comprehensive geospatial data that describe vegetation, wildland fuel, and fire regimes across the U.S. and insular areas. It is the foundational data set used to support fire science, operational wildfire modeling, risk assessments, and fuels management. Currently, the users of landfire data have to manually update data layers to account for fires not reflected in the most recent landfire products. And although on track toward annual releases, the current landfire update latency is about 24 months. A lack of resources and processing time and power limit landfire programs' ability to reach an annual refresh today. Beyond that, there's a need to move from sampled LiDAR to the full use of LiDAR where it's available. LiDAR data will support the next generation of fire fuels information to improve the overall accuracy and fidelity of the data, providing unprecedented information on a pixel-by-pixel basis. Recommend funding to accelerate the move of landfire data processing to the cloud. This needs to include cloud computing costs, data pre-processing activities, and human resources. Additionally, funding is needed to develop the next generation of fire fuels products that more fully incorporate LiDAR data. Next slide. Newer 3D fire models offer remarkable capabilities to help managers understand their options at project level detail, but so far have generally not been accessible to managers due to a lack of 3D fuels data. Fast fuels will accelerate the use of advanced fire models, expanding the solution space for contemporary fire and fuels management problems from project level to landscape scales. In addition to providing 3D raster data for 3D fire models, Fast Fuel also retains individual tree attribute data, facilitating in-depth fuel treatment analysis and paving the way for stronger fire behavior and fire effects interactions. Fire fuels data that move toward continuous structural characterization rather than fuel categories will provide better understanding of fuel treatment effectiveness, more accurate prediction of fire behavior, more accurate emissions estimates, and can also be used to enhance firefighter training. Recommend funding the next generation of fire fuels models such as Fast Fuels. Next slide. Accurate and timely fire detection and monitoring enables decision-making, deployment of resources, and ultimately saves lives and property. The number of sensors available to support operational fire detection and mapping continues to grow. However, there's a lack of analysts available to produce products from these sensors in a timely manner. Additionally, the current algorithms for sensors such as GOES ABI have unacceptably high false positive and missed detections. Funding is needed to support research activities focused on artificial intelligence and machine learning, algorithm development to automate fire detection, enable exploitation of the full range of current and coming data sources, and improve the reliability of existing algorithms. NOAA has initiatives underway to improve the reliability of the GOES algorithms using supplemental funding. However, this needs sustained investment. Next slide. The current generation of coupled fire behavior and atmospheric numerical models have shown an increased potential to predict complex and rapidly changing fire behavior. The next generation of models provide computational fluid dynamics solutions to improve predictions of fire progression and smoke plume concentration and dispersion, as well as predicting the relative effectiveness of alternative fuels treatment. At present, there's no centralized location for wildland fire and ecosystem modeling collaboration among scientists, modelers, and fire managers comparable to the capability developed for tropical cyclones at the National Hurricane Center. There are also no clear pathways to consistently transition models from research into operation. This recommendation is to create a wildland fire and ecosystem modeling cooperative where the scientists, modelers, and fire managers can work together to create and operationalize the current and future generation of fire models. Embedded in the modeling cooperative should be a repository for discovery, curation, and use of models and data products. Next slide. Growing number of commercial companies have high altitude, long endurance aircraft and airships capable of persistent observations from above commercial airspace. These platforms can support multi-mission sensor arrays that can provide high resolution, geospatially accurate fire perimeter information, pre and post fire landscape metrics such as vegetation structure, fuels condition, post fire hazards, fire winds, and radar for precipitation intensity, as well as communications and asset tracking. NASA and USGS and other partners are actively involved in evaluating the maturity and performance of several HAIL platforms and sensors. However, there is a need to expand this demonstration to understand the full potential of these in supporting the fire community and increase payload technical readiness levels. Request for proposals is also needed to expand the number of sensors and sensor types available to be deployed on high altitude and other platforms. Next slide. Acquiring and delivering data to the wildfire community with low latency requires a flexible set of airborne solutions across a range of aircraft classes and platforms. At present, NIFC has only a few dedicated aircraft, such as NIROPS, that generally serve only a single purpose. Beyond those, NIFC relies on contract aircraft to fill gaps in capability. Expanding the government fleet to a broader set of multifunction capabilities and establishing common standards, interoperability, and data delivery requirements for those capabilities is critical. A multi-scale range of interoperable solutions adhering to common standards, providing reliable, low latency data delivery will ensure a more robust, flexible, and more cost-effective fleet for the fire community. NIFC needs funding to define and procure the fleet of airborne capabilities needed to support wildfires. This needs to be accompanied by funding for the appropriate level of personnel and training. Next slide. Okay. A few final thoughts, noted limitations, caveats. While the assessment team was generally confident in the recommendations, there's several factors that really restricted the assessment. We had very limited time to gather information about this really complex, multifaceted, and rapidly evolving topic. The assessment was limited to federal SMEs due to time available, and also the Paperwork Reduction Act and the Federal Advisory Committee Act or FACA restrictions. The team lacked sufficient context to do any prioritization of the recommendations beyond identifying those that appear to meet our low-hanging fruit criteria. And then finally, all of these need additional investigation to determine the time required, the cost, and the comparative benefit. Next slide. And this is the last one, kind of what's happening now. Agencies have been reviewing these and are considering the recommendations internally. We continue to give this presentation to multiple groups just to get the word out and make the information available. And then there is a sense that later in the fiscal year, there will be some assessment of progress against the initiatives. USGO is interested in potentially other groups to seeing what happens with these recommendations. So that's the end of my presentation. Thank you for sitting through what's kind of a fire hose. I appreciate that. I'm open to any questions.
Carolyn, that was amazing. Very information rich and yeah, lots of information to slice and dice there. I really appreciate some of the high points that you hit there in your recommendations list. They really dovetail nicely with some of the things that I've identified. We have time for one or two questions here. Liz Ward from NASA, I guess she's actually with Christopher Newport University. She says, are the results of the study published and available for download?
They're not published. You'll see the markings on here. Right now, they're kind of an internal government use only. If you're interested, I can get back with the government folks and ask about the releasability. I think the sense is that they would hope to move in that direction. We do have a PDF document that has all of these along with all the supporting information. So I think, I don't know if the academically affiliated folks, if we could release it, but I can make a note about that and get back to you.
Yeah, and let's see. Okay. Yeah, I think the rest of the questions have sort of been addressed here. And in the interest of time, first I want to thank you, Carolyn. That was an amazing presentation. Lots of great information, very nicely laid out there. So thank you for that.
Thanks so much.
And with that, let's see, I don't know if these slides are self-advancing, but is Sean Triplett and Tom Mellon online?
I'm here, Everett.
Okay,
Hey, Everett, can you hear me?
I can, Sean, and I have your presentation up. I don't know if you have your PC in front of you, but I'll advance the slides for you.
Yep, I can see it. Thank you. All right. Good morning, good afternoon, depending on your location. Wanted to give you a quick perspective on where we are with the Tools and Technology program here at NIFC, and also talk a little bit about some of the work that we've done in the past, what the status of that is, and some of the projects that we're going to be working on this year. And also wanted to thank Zach earlier today. A lot of the work that we're doing and going to be talking about is in support and collaboration with the work that Zach's doing and others, CAL FIRE, state of Colorado, to help them with their programs. All right, next slide. Okay, so our big push is with Zach on the incident and awareness and assessment side. Zach's more working in the operational and aviation perspective with his partners. We're really on the data management and working to get those products out to the end users in the field. And so obviously satellites are a big deal with that. We're continuing to evaluate and work through different processes to engage with the satellite community. You're going to hear later on today from Canada. We've had conversations with them. We've recently met with several different private companies and also some NGOs or philanthropic organizations that are interested in providing satellite capabilities. And really the whole intent behind using these satellites is to help fill the gaps of observation that we have currently on fires, and then look to see where we can use satellites either as gap fillers, like I mentioned, or potentially be a primary source of information on particular fires. Aircraft is always a growing program for ours. Where we're really helping or hoping to play a role in this is helping on that tactical support where Zach was talking about earlier. Providing that the last mile connectivity, and also some of the what we call the edge processing. So some of the work that we're doing this year is in some partnership with a couple different companies and also with internally to take edge processing and computing out to either a spike camp or directly to the fire line. So if you have an aircraft that is processing or capturing imagery and is able to get it down to the boots on the ground, we would have processing power right there to be able to do on the line interpretation, maybe run it through an artificial intelligence or some type of remote sensing process to get the relative information out of that. And then also to work to increase the ability to get that data to the end user on the ground. That goes across all different flavors of aircraft. So mapping, tactical, and UAS. The ground-based sensors. So this one and the satellite, the recent legislation from the Infrastructure Act pushed out some direction to the field for continuing to evaluate and expand the use of one, particularly the GOES platform for NOAA, but also the ground-based sensors. So currently across the country, we have about 1,700 camera systems in fixed locations or mobile. And we're looking to expand those. And then also we heard earlier about the potential of utilizing ROD stations to do increased observations, also using satellites to do increased observations with soil moistures and other environmental variables. Where both of these programs are happening in partnership with Department of Interior and others. We're looking at starting to build these out as enterprise programs. Up until today, and this year, a lot of the camera systems have been done either at individual district, forest, or BLM unit, and they've been working successfully, but we really need to get a handle on how that's all working from an enterprise perspective for interoperability, and then leverage those technologies so we can build a cohesive system. Last year, we spent quite a bit of time doing pilots across the Western U.S. And in the state of Florida and other areas for doing firefighter tracking. This was a requirement of the Dingle Act, and we accomplished that. And just to let everybody know, there is no Dingle Act compliant tracking devices, and there is no nationwide firefighter tracking program. Those pilots have finished. The results of those pilots have been, a report has been built, and we have sent that up to our leadership at Interior and the Forest Service for concurrence and approval. And then the hopes is that we can then move forward and find budget and programmatic support to build out a tracking program. Yes, there is individual tracking programs occurring in different parts of the country, but there is no programmatic chartered program or funding approved to take this project any further than where we are right now, which is finishing up our report, getting the report approved, and then moving on to looking at the potential for a nationwide program. So that's about really all I can say on that. I know I get pinged constantly from vendors and universities and others wanting to participate in the firefighter tracking program. But I just want to make it very clear that we've done the pilots, we evaluated the systems, we've built recommendations, but there is nothing occurring right now for a nationwide implementation of tracking firefighters. Next slide. So one of the things that we're working with Zach and others on is right now we have a lot of different approaches that are going on out there. I think it's kind of it's incredible, but it's also mind-boggling to me when I hear about all the different modeling that's occurring, all the different grid ideas. We've got little centers of people trying to do what they think is best for the fire community, but we really have to understand that fire is a nationwide problem. It's not a Southern California problem. It's not a Sierra Nevada problem. It's not a Front Range of Colorado. It's not a Texas problem. It's something that we all need to be working at it from an integrated approach. And so really what we're working to do with our interagency and intergovernmental partners is to get out of the good idea factory and the different silos of expertise and programs that are out there, build a cohesive strategy, which is a very big word on the fire world, phrase in the fire world, to build that programmatic approach and then build an integrated system so that at any given time we can look across the landscape and have an understanding of what the fire problem is currently, where the fire problem is going to be when we look at fuels and the drying of the land, the loss of water in the Western US or the encroaching development in areas. And then looking at it from a post-fire perspective, which I don't have a whole lot of area in, but as a lot of attention's being focused on the Southwest right now and trying to handle the suppression activities that's going on with the fire. But from a programmatic approach, what's happening now should be tipping and cueing the next step, which is what are we going to do when the monsoons come for the runoff and the flash flooding and those. I know the bear teams and everybody else is getting spun up, but again, that's occurring at individual agency perspectives. There's probably been about 15 models run that's going to tell us what the potential is for flooding, but are we working to bring those together so as a body, as Americans, we can look at this and understand what's happening. Next slide. So really, and I think if you hit a button, Everett, the little puzzle will fly in there. There we are. So really what we want to look at is technology as a piece of the puzzle. We know that technology has to come together as a system. It cannot be something that's individual implementations. It's not something that can just be built, deployed, and then look for a managing agency to pick it up. We really have to work at this and it just shouldn't be the feds. We should be really looking at our state and locals, our philanthropic, university, other organizations to help us get through some of these areas. And then it should really be tied to a requirement. I heard one time that, well, we don't want to do that because that'll stifle innovation. Okay, well, then that's why we have 15 different models telling us 15 different ways a fire is going to go right now. We need to come up with standard terminology. It seems to be in my world, risk is the #1 word when I talk to anybody, but can anybody define risk? Yesterday, we had yet another system that was produced that's going to tell us what my individual home is and a risk to a wildfire. That's probably, I can think of over my career, that's probably the 15th nationwide risk assessment that was done. Are we really being the most efficient with our tax dollars and our limited program dollars by continuously to identify these, or should we be looking at how we can do use the technology, the data is collected to be more operational, more understanding, and be better prepared for when those fires happen? And the biggest thing of all is all this technology, all the data that's associated with it, it really has to be packaged into bite-sized pieces of information, because the reality is all that information is going to go through the funnel, and on the end, it's going to come out. And at that other side there's going to be a decision maker. There's going to be an agency administrator, a firefighter. It could be someone on the ground in a task force leader type position. It could be someone sitting at a GAC or a MAC group trying to figure out where they're going to go with resources. Are they receiving it? Do they really understand it? And are they actually using it? Or is it just because it's getting to the point where it's so complicated that it's not being used? So are we really looking at how effective the work that we're doing is going into changing the way that we're managing fire? Or are we just putting a lot more technology and a lot more data out there, but continuing to do our jobs the same way? Next slide. And that's what I have. I wanted to keep this short and give Tom time to talk about the program that he has. I mentioned earlier about the Dingle Act and the resource tracking programs we did. If you click on the link, it's in the PowerPoint. It'll take you to some story maps that we produced. It shows the work that we did last year. So thanks, Everett.
Yeah, thanks, Sean. That was great. I particularly like that technology puzzle slide. I think that was very instructive for all of us that are working towards solutions. So thanks for that. Tom, are you out there? Can we get a sound check from you?
Yeah, I'm here.
Okay, go ahead.
Thanks. So I'm Tom Mellon. I'm the National Infrared Program Manager, also known as NIROPS, and I'm going to focus in just on this one program, which, as we've seen, is a small part of the larger puzzle, but is probably one of the, if not the longest lived fire mapping and detection programs out there. Next slide. So NIROPS is a Forest Service program that flies fires with thermal sensors and delivers critical fire intelligence to requesting incidents. And that information is delivered as GIS files, shape files, geodatabases, as well as uploaded directly into the National Incident Feature Service. And then for non-GIS folks, KMZ files and GeoPDF maps are also produced with the same information. And then there's also an interpreter's log, which acts as kind of a briefing to discuss fire growth, imagery issues, anything of note, and as well as provides documentation. And these are internal products delivered to the incident management teams in time for the morning briefing, typically by posted by 4:30 in the morning, so that particularly the GIS information can be incorporated into other maps. Next slide. Just to look back at last year, yet another long season, although really when you look at the 10-year CONUS average, we were right at about 100% of our 10-year CONUS average. What was notable was the duration and the intensity of the season. We went to preparedness level 4 on June 22nd, which was the second earliest date ever, and didn't go back down to preparedness level 3 until late September. So that was 99 days, the most days ever at preparedness level 4 and 5 since that system was implemented. Our first mission was April 26th in Arizona. Our last mission was October 30th in California. Next slide. And what this shows is going back to 2006, this tracks on our online ordering site the number of requests that have come in, as well as the number of requests that we have been able to fill. The red bar is the total number of requests, and the blue bar is the number that were filled. And so what you see is in 2021, we kind of smashed all our previous records with just under 4,000 total requests. Every night that an incident requests a mapping flight, that counts as a request. And just over 2,800 of those were filled. And I'll talk about the number of assets we were able to bring to bear last year. What that ended up being was a very low non-weather UTF rate. That says 6%. I think a number got deleted. I think that should be 16%, which is still significant. Infrared thermal sensors can't see through cloud cover, so that's a large measure of our UTFs when weather starts to come in. In addition, Aircraft 3 filled just 1% of our missions last year. That's assets from the DoD side, but I do want to call them out because they provide critical coverage at time when our Forest Service planes or our vendor planes are not up, maybe going through maintenance and not able to fly. In particular, this year, early in the season, with New Mexico and Arizona kicking off very early, the DoD assets, in particular, the additional analysts from NGA and USGS, were key in providing support early on for the missions. Next slide. So last year, this is just to give you an example, our busiest night in terms of the number of fires flown, not necessarily the number of acres flown, but 48 fires. As you can see, we brought a number of assets to bear. Our Forest Service plane, our King Air, was covering a number of fires, but we also have contractors. 10X as our exclusive use contractor, and then on this particular night, we had 2 of our end product contractors, each able to field 2 planes to cover fires across 6 states and cover those gaps. Next slide. So those IR mapping contracts, as I mentioned, we have 2 planes through an exclusive use contract with 10X based out of Boise. And then we also have 5 different end product contractors strategically located around the country. Now, our end product contractors with their aircraft and sensors can't cover as much ground or map as much area as our Forest Service plane and our exclusive use contractors. So we typically assign them to anywhere from 1 to 3 fires in a geographic cluster. But that's really enabled us to increase our geographic reach. There are areas of the country, for example, northern Washington, Idaho, and Montana up near the Canadian border, or Southern California, that we've always struggled to cover when we had activity going on across the entire West. And we were able to fill a lot of those gaps last year because we did have so many contractors in the mix. Next slide. So for Forest Service aircraft, we still have 149 Zulu, our King Air 200. It is currently flying the fires in New Mexico. Manufactured in 1985, over 18,000 hours on the airframe, and had their 6th engine rebuild last year. Returning to Ogden most nights to get some nightly maintenance and touch-ups that you would need in an aircraft of this age. We are eagerly awaiting our 2 new King Air 260 aircraft. Currently scheduled for June delivery, and we're hoping that time frame does not slip. It will have a multi-sensor pod so that it will be able to accommodate the Forest Service Phoenix system, an Overwatch TK9 system that was purchased by the Forest Service, as well as the NASA AMS system that was given to the Forest Service. And it will also have an Inmarsat data link, which will be a huge improvement over the current AirCell system, allow us to push off potentially higher resolution imagery and larger files much quicker. Next slide. So our 2 infrared techs, Michael Mann and Kaz Casimir, have been working for a number of years in developing the Phoenix Next Gen system. And the idea is basically going through the whole system and updating all the components to extend the operational life, miniaturize, and bring up to date the digital electronics, greatly reducing both the weight as well as the footprint profile in the aircraft, and improvements to the imagery, enhanced orthorectification, and making the imagery clearer and sharper. Next slide. These are some components of that system: new motor and controller for the scanner, new INS system, single board computer. We've now have cryo coolers, so no longer having to deal with liquid nitrogen, and new components, and move to 64-bit operating system. All of these have been implemented with the exception of the new mirrors. Ran into some hiccups in contracting, so that will be on task for next year. Next slide. And this is just a view there. You see the scanner in both views, but the greatly reduced size of the computers and the IMUs. And in the end, when we remove that, when we no longer need that rack, large rack you see on the right, it will have a much smaller footprint in the aircraft. And one more slide, I believe. What I wanted to show here, this is some of that imagery from the Phoenix Next Gen. This is from the Hermit's Peak Calf Canyon fire, the one that's been in the news so much. It's approximately, as of this morning, it's just over 300,000 acres. It's become the largest fire in New Mexico history. It's about 45 miles long and 19 miles wide, and it's taking the Phoenix system about 35 minutes to fly and process this imagery. This particular image here is back from the 10th of May when the fire made those runs to the north and grew by 33,000 acres, which, you know, that used to be a very rare occurrence. But now in the last few years, we're seeing those kind of 24-hour growth rates quite a bit. And Everett, I think if you click once more, you kind of get a zoom in on some of those runs on the north. And with that, see, are there any questions for Sean and myself?
I just wanted to comment on some of this newer imagery. It's really the sharpness on this new imagery is pretty amazing. So I would like to give kudos to Kaz and the folks up there in that shop for continuing to work away at the Phoenix system and improve those systems as we transition to new aircraft. And yeah, it's pretty remarkable. Let me check the chat here. I don't recall seeing anything for you or Sean. Let's see. Let's see. Sean exchanged information with Scott Kaplan. I don't see anything else. Remarkably, we are pretty much right on time for our first break. And I'm kind of patting myself on the back for giving us a full half hour. I would like to have given us an hour, but we'll have another half-hour break later on in the day. So as of right now, it's just very close to 1 p.m. here on the East Coast, and we'll pick up again in a half an hour. So I encourage everyone to get up out of your chairs, stretch your legs, get some fresh air, get some food, whatever you need, coffee, and be back here in a half an hour. And I'll put up a slide to let folks know that we're away on a break here. So thanks everybody. Great presentations this morning. Thanks to Tom and Sean for great presentations there at the end. So yeah, take a well-needed break here and be back here at 1:30 Eastern. Anything else from Vince or Birgit?
Just want to mention that in the second block after the break, we'll be focusing on some more of our additional partnerships from the federal government, state enterprise governments, and our Canadian colleagues with an update from the Canadians on the Torchlight system and the TFRSAC program that's maturing up nicely in Canada. So we'll be continuing kind of with these baseline presentations by the organization leads of TFRSAC. So thanks, everybody. See you in the next 25 minutes, half hour.
Josh Johnson, are you online?
Oh yeah, you know where to find me, bud.
How you doing?
Oh, good. It's frantic around here, but in a good way.
Well, yeah. Sometimes frantic can be good.
But it's not
So-
boring.
Yeah, I don't think my kids complain of being bored sometimes, and I said, I really wish I had the luxury of being bored sometimes.
It's true.
So we're coming up here. We got a couple more minutes yet, but I'll bring up your title slide.
Cool.
You got to redefine boredom, Everett. Let them understand what boredom really means.
That sounds like Vanessa. Yeah, the boredom thing. So I got this picture of this. This is from New Mexico, and Richard McCrate, who may be online, sent this to me just a little bit ago. He was up in that area, I guess, over this past weekend, and caught this picture of the fire plume. This is probably the Tom Mellon. What's the big one up there that you mentioned in your presentation? I know it's something or other peak.
Hermit's Peak, Calf Canyon.
Okay, yeah, this is probably that one. But anyway, now we got a couple more minutes. So Josh, have you had unusual spring weather this year?
Yeah, it's been a very late spring, and then all of a sudden we had a pretty rough heat wave, and then it was back to frost last night. So who knows, man?
Right.
I think in the north, like north of me here, there's still quite a bit of snow in the bush, but we've got a bunch of fires that are over 1,000 hectares too. So how that happens with, a foot of snow on the ground, I don't know, but it's ugly.
Is Alan joining you here today, or are you here solo?
Alan's here, but I think I'm the only one talking.
Okay.
Yeah.
It's kind of like when the Cuyahoga River caught on fire in Cleveland.
Yeah, don't remind me of that. I'm from Northeast Ohio, so that's sort of a painful memory. It was the
Just
butt of a lot. The butt of a
The
lot of
last person
jokes.
out of Cleveland turn off the lights, right, Everett?
Yep.
Oh my.
So
I
I
think of one reason a river catches on fire and it ain't good.
right. Vince, are you online? I think you're going to queue us up for the second block. Is that right? Oh, Rob Miller says he's from Ohio too.
Yeah, I'll do the introductions for a second block. You're still going to run the slides, though, I guess, Everett, right?
I will. Yes. Yep. They're all queued up here. So I have 129. So you can take it away at your leisure, Vince.
Okay. I'll give it another minute.
Yep.
And Josh, is Alan speaking too? So I'll introduce you both.
Nah, it's just me. Alan
Okay.
gets a pass today.
Okay. Well, I'll mention him as your cohort on this cohort.
Okay.
When my grandfather clock strikes here, then that's the official time I'll start.
Is that pretty accurate, Vince?
Yeah, it loses about 2 minutes during a week from when I have to wind it on Sundays, but it is 120 years old.
Yep. There's Josh. I'm going to go ahead and mute my camera here. There it is.
There's my Bing. Is my camera on?
No.
Can't. Well, that's weird.
We couldn't see you even if it was, Vince, so.
No, it should be good now. All right, then I won't even use it.
All right, I think we're there.
All right. Good morning, good afternoon, everybody. Welcome back from the break. This next session, we label it Block 2. We're going to get updates from, again, a number of our colleagues from the various agencies and updates on various meetings that we've had over the past 6 or 7 months, updates from that community as well. But to start out with, we're going to get an update from Josh Johnson and his colleague Alan Canton. Josh will be speaking today on the Canadian update to torch fire and I'm sorry, Torchlight and the Wildfire Sat program. And I think it'll primarily focus on WildSat, right, Josh?
Yes, sir, Vince. I mean, Torchlight's live and well, but we're still waking up for the year, so not a whole lot to report right now. On the flip side, WildfireSat has grown new legs, and we might as well focus in on that today. So folks, I think if you've ever heard me talk, you're probably sick and tired of hearing me talk about this mission. But we've had a major development, and I think you can all agree that it's worthy of talking about. On April 7th, the federal budget came out, and after a lot of years of trying, we received full funding to make this an operational mission. So, historically, we always talked about it as being a pathfinder, the first of 3 satellites required for the constellation. Yeah, I see the applause. Thanks, lads. Now we have full funding to put up all 3 of them, to downlink all the data, to process all of it and deliver an end-to-end information system, including a rather ambitious knowledge exchange program with our end users, the fire managers in Canada here, which is already underway. So if you can imagine that, a whole of government space mission in which the provincial and territorial fire managers are full partners and participants in every stage of it from start to finish. So yeah, I don't know where to even say from that. It's easy to talk about these things because you never expect to actually have someone give you that kind of money. And then once you do, you just realize how quick your hair is going gray. So let's go to the next slide, and we'll actually explain what we're all up to here. So if you aren't familiar with the mission, here's the premise. If we go to the next one. So we're looking at a polar orbiting mission. The issue, of course, that we're dealing with in Canada, high latitudes, very, very poor performance of geostationary up here. We rely on polar orbiters, but we don't have any that are providing that near real-time data right in that peak burn period, late afternoon. So that critical gap is what we're trying to fill here. And if you go to the next slide. Oh, yeah, it's just a cute little picture. That's where we're putting WildfireSat. You can pop on to the next one here. So what the satellite itself is actually quite similar to VIIRS data in a lot of ways. You're going to have your visible and near infrared in the 200 meter-ish range, the mid-wave and long wave, both at 400 meter. They are tuned for FRP, so very, very high saturation points on those. Not necessarily the best performance on surface radiance if you're just looking for land cover temperature. It's not primarily designed for detection. This is very much a monitoring mission. It's designed for surveillance, for tracking the change in fire activity in that late afternoon period and providing some analytics regarding the fire behavior, its progression and whatnot. And it's doing that by forming a virtual constellation with VIIRS. So the data matches the structure of the VIIRS data. It comes a few hours later, and it's really looking at how that active fire has changed in the late afternoon. If we go to the next slide. Yeah, this is just kind of a breakdown of the products. They're in flux to some degree. But in general, we have our tier 1 stuff, which is that core data that has to come out of WildfireSat in order for us to start getting to work. Tier 2 is those higher level analytics that are really happening because we're comparing it to what else came out of other satellite data, primarily the VIIRS data. And then in tier 3, we actually move into ancillary modeling products, pulling in data like data layers that are either static or dynamic. It all depends on which fire management agency it is. And there's also some peripheral products that are sitting in here that the team will be developing. And those include things, so like our fire managers have explained, particularly the ones who have remote access fires and like proper remote, the way that only Canada can do. Some of those fires, they'll never action them, but they have an obligation to fly out there every single day and map them, which is not cheap. And it also requires experienced personnel to be stuck in an airplane instead of put on a line. So for them, they say, well, WildFireSat's an excellent tool. We can use that to do our recon every day. Well, but if they get to the end of the day and they don't got no WildFireSat because of cloud cover, that's going to, really impact their trust in it for tomorrow. And so what we've decided to do is at noon, we'll provide a product to them that basically gives them the probability of having cloud cover at 1800 for each of their target fires. And that'll let them make an educated decision at noon about whether they want to fly it or they want to roll the dice and see if we're going to get WildFireSat later. And those types of peripheral products, those are the kinds of things that knowledge exchange program is starting to build for us. And it's been quite interesting working with them. If we go to the next, I think ultimately the real important thing is, yes, I do like to steal phrases from Sean Triplett, but this mission really is about information, not imagery. In order to meet our timelines, we're not going to be trafficking imagery to our end users in near real time. We will be doing product calculations and production right at the site and transferring those products just because there's so much more lean to move around. If we go to the next one. Okay, so I'll give you a notion of where we're at and what we're actually looking at. The mission is finished phase A. In the fall, we're going to kick off phase B with our new scope. And this is, once we get through phase B, is when all of the specs of the mission will actually get launched or locked in. But as it stands, here's where we're at. If we go to the next one. So as I mentioned, it is a 3-satellite constellation. This is being done for a number of reasons, most importantly to constrain the viewing angles. And that helps us get very uniform swaths. The pixel size from one side to the next is almost identical. It also means that you get the best viewing geometry for FRP measurement because fires are not Lambertian radiators. Looking straight down at them is much better. It's not like a 120-degree phase, though, if you take a look. It's about a 90-degree phase, and that's all just optimized for your altitude and your swath widths so that the 3 satellites functionally have near identical overpass times. So you won't necessarily be aware that there's 3 satellites when you look at the data. If we go to the next slide. So this is your absolute worst case revisit time. And I'm putting this up here for the simple reason that the actual coverage is designed to be, best in the far north, right? That's where we actually have to meet our mandate. There is of course, a modularity to the system. I think if we added 2 additional units, you would have that green coverage, from top to bottom on the globe here. As it stands, you start to see a little bit of separation as you move to the south. And once you hit the equator, there are times when you may have a single fixed point on the ground that gets missed for 3 days. Now, the way the orbit tracks are set up, they're always shifting. So if you got missed by 3 days 1 week, you wouldn't get missed by 3 days the next week, kind of thing. So this map is your absolute worst case, how long you would end up waiting in a given week. How long would it actually take you to get a second pass? So again, wherever you have really good geostationary coverage, you're going to have less WildFireSat coverage. Where you don't, you will. If we go to the next one, to draw attention to the fact that our coverage for downlinking is over Canada. These are the actual line of sight from the CCMEO ground stations, the Government of Canada ones that we're going to be using. The way the mission is designed, it's bent pipe downlinking. That's part of how we're delivering that data in such fast pace here. And if you take a good look at that, you get the sense that, okay, look, we're going to cover Alaska. That's default. That's not even us being nice. That's just the fact that even if we tried not to, we would accidentally cover Alaska. So that part's covered. And the northern US, we will have coverage as well. But in order to actually deliver the data globally, we need to actually set up data distribution or sharing agreements where anybody can have it. There's no problem keeping the system running 24/7. It never needs to be turned off. Basically, once per orbit, when it's over a water body, we put it through a calibration cycle. But all we really need to do is coordinate downlinking access in different regions. And if you got a ground station and we can hook it up, data's coming to you. And we'll hand out all of the software, obviously, as well. If we go to the next slide. Oh, a couple of technical specs. Yeah, we'll bounce through these quickly. Next slide. So just in general for the mission itself, the LTAN is intended to be at 1800. Your descending node will be at 6 a.m. Altitude is nominally at 650, but again, those things are going to get sorted out later. So if each one of the satellites had a 400-kilometer swath, you know, the actual total is a little bit under 1200 because there has to be a slight amount of overlap so you don't get missing spaces. But maximum co-elevation is 20 degrees. So very, very strong uniformity, and you will have edge-to-edge usable data in that swath. We don't actually count any of the swath that exceeds that 400-kilometer because there is pixels that exceed it, because we don't consider them to be high enough quality for the for our purposes, and so they're not recorded here. If we go to the next. If you are interested, I threw this in here. These are the downlinking specs as they stand, but you know, we won't get into them at the moment. That's just for reference, folks. Next slide. The payload itself, it's an interesting thing. It's all based on microbolometer technology. Very, very low power. I think the thermal payloads are, you know, they consume something on the order of 4 watts. Which is certainly something that makes it a lot more cost effective and a lot easier to keep running 24/7, right? These specifications that we're showing here, these came out of phase A, and there's a trick to how these are worded. So the threshold ones are literally, we have no option but to exceed those. If you hit the threshold, the mission is a failure. The goal is kind of where we want to be, and we believe realistically we can get there. And that is something, what we found right now is that the actual technology has advanced enough that we should be hitting those goal requirements or exceeding them. If we go to the next. Yeah, just to note that because it is a bolometer, we do have to have an onboard calibration source. We don't, I mean, people will argue maybe you do, maybe you don't. We do. And we're not taking that to chance. So each satellite will have its own dedicated black body. Next. General timelines for you. Well, it looks so simple when you put it down like that, but the truth is we got an awful lot to get done between now and launch. We're going to launch around Christmas time in 2027 and be online and operational in 2028. As it stands, we're funded for 5 years of operation, but extending the mission beyond that is not particularly expensive. So we'll just see where it's at the end. The next. So next steps. Whole lot of briefings. Believe me, people, if you've ever tried to get money out of the government, it is tricky. Once you got it, there's a whole lot of people who want to know about it. So there's a lot of briefings going on. Also trying to get the funding actually flowing so that we can kick things off. On my side, because the downstream side of it needs an awful lot of work, there is an extensive staffing going on our side right now, and a whole lot of development that needs to start occurring immediately. From the science maturation side of it, the science plan is pretty much complete, and we're already beginning on some fronts of it. But because we need this to be fully operational on day one, and we need our fire managers to be fully ready to actually consume it, we are planning to be generating synthetic WildFireSat data as part of a fire growth modeling outputs that are driven by VIIRS. So if you can kind of follow that train of thought, within 3 years, we're hoping that every time you get a VIIRS detection, you'll actually get a WildFireSat simulation at the right time so that people can actually work with that. And so on that, I'll call it a presentation.
Great, thanks, Josh. We've got one quick question I think we can answer fairly quickly. It's from Ed Heyer. And he asks, are the TFRSAC detectors actively cooled at the midwave? And also the adjacent question to that is also, are they cooled at the TIR, thermal infrared wavelength?
Yeah, no, they're not. Microbolometers generally do not need to be cooled at all. There is what you call a thermal electric cooler that just stabilizes the detector temperature, but there's no active cooling going on. That's why it only takes 4 watts. But you do end up having to have much better optics, like F1 optics, to work with that.
Cool. And I know we got another question there from Deepak, but we're running short on time, so I'll let you answer that question in the chat.
Can do.
We'll move forward with that. Thanks, Josh. Great update too,
Thanks.
and congratulations on getting the funding in place to start this new initiative that we're all looking forward to sharing with you on.
Thanks, man.
All right. See you in a couple weeks too. All right. Next in our series is Tim Chavez and Phil Saleg. I think Tim will be doing the presentation from CAL FIRE on the CAL FIRE update. Tim has been a long time partner in the TFRSAC meetings and was reintroduced to our group again most recently as he's moved to the Sacramento office at CAL FIRE. So welcome back into our neighborhood, Tim, and re-welcoming to you back to the TFRSAC community, and we're ready to let you go. So.
All right, thanks, Vince.
Take it away.
Can you hear me?
About 15 minutes. All the presentations during this time period, I'll remind each of the presenters, is 15 minutes. Thanks.
Can you hear me, Vince?
Very
Hear you
well.
fine.
All right. Hey, thanks, Everett and Vince, for inviting us again. We're happy to be here. I have a pretty short presentation, so I'll probably let you catch up on some time. As Vince said, I have moved from a fire going position into an administrative position at Sacramento headquarters, dealing with Intel and specifically something called the Wildfire Forecast Threat Intel Integration Center, which I'll talk about a little bit at the end. It's still kind of in the we're building the plane as we fly it kind of stages. Next slide. Can you advance my slide? There you go. So we have a few things going on. Our Intel, CAL FIRE Intel has really expanded in the last 2 years from what used to be a part-time job in the 2 geographic area coordination centers, north and south, Reading and Riverside. We now have full-time staff and 2 people on duty 24/7 in both of the GACs, and their complete job is intelligence gathering, supporting incidents with intel, and providing information to our leadership. The tools we're using, we'll go over a couple of the tools. One of the important tools that we're using is the alert wildfire cams. There's something like 1,000 cameras in the Western United States, 1,700, I think. They're on a lot of mountaintops. There's multiple cameras on mountaintops. Some of them are equipped with infrared. Some of them are equipped to do NDVI, so a kind of a side benefit of having all these cameras all over the place we're finding is that they allow us to track the curing of the fine fuels as the spring goes on. And since spring is getting shorter and shorter, that curing process timing is becoming more and more important. There is multiple efforts out there to use the alert cams for detection. And I am a detection skeptic coming from California, where almost everybody has at least one and probably 2 cell phones. Detection in California, except in the remotest locations in the Eastern Sierra or high elevation, is not an issue. We get multiple. If you have a fire, if you're in one of our dispatch centers and you have a going fire, you know it because the phone is ringing off the hook with people wanting to report the fire. So as a general rule, unless it's a lightning bust and unless you're in really remote country, detection is not the problem. Confirmation, though, is an important benefit of having the alert wildfire cameras. A 911 dispatcher or a supervisor in one of our command centers, as a report comes in, can swing the camera around, look at the smoke, relay that information to the field going people, and almost immediately we know, except in unusual circumstances, whether we really have a fire or not. And we're finding out you can learn a lot from the character and the color, shape, size, extent of the smoke as the emerging incident begins to accelerate or take off or whatever. And again, it informs our decision making in that important incipient stages of the fires as they come into our dispatch centers. So we're finding out that this experiment that started in the early 2000s with a few university cameras, and actually the cameras were kind of a side benefit. The initial project was to provide internet access to remote locations in San Diego County. And that camera turned out to be a side benefit that now has pretty much become the main benefit of this system as the system has grown, and our investor-owned utility partners have added cameras, and other departments have added cameras, and it's just really expanding. Next slide. FireGuard. FireGuard started 2 years ago. They won't tell us what it is, kind of like Aircraft 3, but it's a military asset with interpreters and analysts that are looking at the Western United States 24/7. We have one center in Sacramento area, one center in Colorado. They divvy up the Western United States for detection and progress tracking of wildfires. There's some question about the accuracy and precision, but we're finding that as the fire gets bigger, the accuracy and precision gets better. And what the FireGuard tool is really good for is tracking the progress of an existing fire. And it's every 15 minutes, 24 hours a day, 7 days a week. We're finding great use of the data for calibrating fire spread predictions, for planning and executing evacuations of civilian populations, for in combination with AVL and some of our common operating pictures, we can kind of watch out for the safety of our resources. So it's having this is like a dream come true to me, somebody that has been in the business for 40 plus years. The two amazing developments of my life have been GPS and now this, being able to have almost real-time position of the fire and then knowing where your folks are on the ground. It's an amazing time to be in this business. The decision support that these tools provide is pretty amazing. The old way that the FireGuard used to report was they used to give us these emailed or text spot reports. Now we're getting the data included. It shows in EGP, and it shows in our common operating picture, which is Techno-Silva Wild Fire Response Tactical Analyst. The initial attack fire ground commander, if they have connectivity, can see the progress of the perimeter on their fires. Like I said, almost in real time, and that in combination with the automatic vehicle location is really a really powerful tool for decision making. Next slide. Sorry, I didn't know those were animated like that. So there's metadata behind the FireGuard polygons, and there's multiple ways, like this slide shows, to get the data. ESRI field maps, Google Earth, EGP, and our common operating pictures. We also still do have an email alert that goes out, and it has information like who the dispatch center is, what the jurisdictional agency, the agency having jurisdiction is, a little blurb about the weather from the nearest RAS station, and then a link to either a Google map, a AGOL map, or EGP. So for those of you can go into FireGuard, into this area of interest. You can draw your polygon if you're an initial attack incident commander, and say this square on the left there is your battalion, and your phone will vibrate every time FireGuard picks up a polygon or picks up a heat polygon in that square that you drew on the map. Similar to what some of the Weather Service forecast offices are doing with GOES heat detection. Next slide. All right, so we're, as I mentioned, our common operating picture is a tactical analyst from Techno-Silva, and we've specified and helped design this common operating picture so that it can ingest multiple sources of data, including FireGuard, including GOES, including MODIS and VERS. Also to include these, we find that whenever we go to a fire, people come to us with assets. It doesn't happen as much as it used to, but one thing that we always seem to get when the fire situation gets pretty dire, when we're in PL5 and max mode 4 in California, is the National Guard starts to help us out with aircraft assets. The MQ-9, pretty common when we're in a big fire siege, can loiter for a long time, as you all know. We've been able to feed that data, the motion video and the operators that capture into our COP. The RC-26, which we're hearing kind of disturbing rumors that program might be coming to an end. But it's been a good platform to ingest data, and then commercial aircraft. Next slide. And again, we're using it for lightning recons, for in-unit fires, for large fire progress, same as what everybody else does. Next slide. So one quick thing I wanted to talk about is we're working on this multi-agency initial attack or incident awareness and assessment order form that we're hoping to daylight this year, that allows teams, type 3 teams, type 4 teams, type 1 teams to go in and order the remote sensing assets that they need and when they need it. What do you need and when do you need it? That's basically what the form is trying to tell us. Next slide. FIRUS, this is a platform that is in our proposed budget for the governor this year, and it is has a sensor and can fly. The concept of operations was it was going to be an initial attack aircraft to fly over the fire, provide data down to the ground, and that will be in our arsenal this year. And then I think there's one more slide. We have taken one of the surplus Beech King Airs that we received from the Navy, and we have also loaded a sensor in it. It has a TK9 sensor, and we will have that this year as well. And that's all I got.
Thanks, Tim. Great to see that CAL FIRE is acquiring some aircraft and starting their own program. It'll be a great benefit to the fire community in California and to the populace in general in California. You don't have to rely on NIROPS as much anymore, and that'll relieve the NIROPS airships for performance in other regions of the United States, obviously. With that, I don't really see any questions for Tim, but if you do have any follow-on questions for Tim, please put them in the chat. And Tim, if you can have an opportunity to check that chat every once in a while to see if there's any questions you can answer on the chat, that'll give us a recorded version of your responses and the questions for sharing with the community later. So thanks again, Tim. Great to see the current uptick of information gathering systems for the state of California, and great to have you in our neighborhood again in Sacramento. Next speaker is Parimal Kapandekar, who's known to us affectionately as PK. Easy enough to use his initials as his introduction for his name, and his presentation is on the findings from the February 22nd NASA system-wide safety workshop that the aeronautics program performed back in February. So he'll give you some of the results from that virtual workshop that was held earlier this year. So with that, PK, take it away.
Thank you. Thank you, and congratulations to again Everett and Vince for this successive TFRSAC workshop. My new saying that the only things that are final in life are taxes and TFRSAC. I think you guys have really made a tremendous impact for the last 20 years in building this community of interest. So really deeply appreciate your persistence and the kind of collaborations and nurturing environment you created is really noteworthy and a model for many of us to continue. So thank you for your dedicated service, both of you. I'm deeply appreciative of opportunities you have given the aeronautics community and embraced us in this. The next thing is I'm here to really talk about NASA's system-wide safety workshop we did, and the two pioneers in that are Dr. Natasha Nayogi and Summer Brandt, who actually were the leaders in making this workshop happen, and this was their idea. And I'm merely representing their work. So thank you for Natasha and Summer Brandt for their leadership in this area. And I think they may be in the audience and they will be happy to also answer more questions as we go along. But we are really looking forward to continue the collaboration with you all on building this safety related focus in the wildfire operations. As you know, there have been many accidents and not a year goes by without an accident that happens in the wildfire fighting operation. And we are determined at the system-wide safety is determined to reduce that drastically and eliminate if we can. Next slide, please. So we held a workshop to understand the community's interest. This was in March through NASA Aeronautics Research Institute, and Natasha and Summer with help from many folks build this workshop to try to understand what exactly is the focus should be on the safety oriented discussion, understand your current challenges and how can we leverage the expertise in NASA has inside system-wide safety with decades of work on stall prevention and avoiding controlled flight into terrain and many other aspects of improving the safety of the aircraft itself. So we focused the workshop goals on safety-oriented risks and the gaps in the capabilities, any processes that we need to improve, and help build near-term and long-term concept of operations. In addition, they also want to build basically demonstrator series as to how can we show that the techniques, tools, and procedures that we will build together with you will improve the safety of these operations. So we want to engage with the community of interest in defining these emergent needs and then put them in practice through demonstrations and so subsequently technology transitions. And as you all know, this environment when the wildfire fighting is happening is very harsh. The weather is not understood very well. Sometimes the communication and navigation is not reliable. Uh, Surveillance is not available. So all these challenging cases, how do you make sure that you can continue to do your operation, surveillance and suppression and communications in spite of the challenges that you had to face? So this is what the system-wide safety focuses on. Next slide, please. So the goals of the workshop were identify the key safety challenges in the wildfire fighting, identify any partnerships and engagements we want to cultivate with you all. Obviously, we are doing this together with you, for you. So it's really critical that we have great partnerships and collaborations with you. And specific goal was to foster these connections and identify activities that can culminate into technology demonstrations as well as transitions. And the scope, we obviously looked at entire spectrum fire cycle from pre-fire for fuel and control for fires and control burns, detection, the tracking, logistical deployment, active fire mitigation, and post-fire surveys. As you can see, anytime there is aerial operation, there is a risk involved, and system-wide safety project wants to try to minimize that risk. During the pre-fire, when you're doing control burn, there have been incidences where the fire went out of control, and nothing that could have been immediately prevented. But if maybe there are better tools that can be brought to bear, in terms of managing the safety and using the safety methodology with basically layers of safety paradigm. And detection and tracking of the fires, of this information integration, making sure that we are able to detect it with this certain precision or give that risk associated with that precision so that people actually on the field can make the decisions using that information, not just dumping them data, but having them decision-friendly information. Deployment is also critical. There have been situations where some drops that came and they actually hurted the troops on the ground. So the water retardant drops. So I think how do we actually make sure that the logistical deployment is in sync with the operations and the safety of all assets and people are guaranteed. We were actually asking, it's an interesting thing. We were asking the first question, like what do success look like in any another context to the number of folks? And they said, having people come home every day, all of them that were they came back home, that would be the first success. So I think that's one of those things that safety cares deeply about. So regardless, we want to identify the common themes that we have done in the past in terms of improving the safety of aircraft operations as well as airspace system, and then figure out how we can enable those and support these for wildfire operations. Next slide, please. So we had 460 registrants, number of playbacks in a day. You can go back and take a look at it if you haven't yet or want to go back and look at what we have done in the workshop. We had a number of keynote speakers from our top bosses as well as key researchers, and we had presentation from the ongoing activities, something we call stereo, which you have heard in the past, scalable traffic emergency response operations project, which maintained the relationships and culminated into significant partnerships with Forest Service and CAL FIRE, that Joey Mercer and Dr. Marcus Johnson started, and we are continuing that onto the next years, subsequent years as well. We had a number of panels that looked at perspectives from federal, state, local, tribal governments, their specific needs, the coordination, and how the roles, responsibilities, particularly in the context of safety, are attributed into the entire system, fire system. A number of breakout sessions where we try to collect the information and coalesce that for potential collaborations and really trying to figure out the specific focus areas where we can contribute to improve the safety of the wildfire mitigation. Next slide, please. We're still going through the workshop inputs and analyzing them. There are a number of key partnerships have been already identified, so with tremendous success already in terms of that that workshop. You can see the report there at the NARI website at SWS-wildfire. If you search that, you will be able to get all that information very quickly. Next slide, please. So as I mentioned, our main purpose is to create the safety products and lead up to the demonstrations of those products so that we can transition them for stakeholders' use. So here are a couple of areas that have been identified. So common situation awareness. Everybody has talked to us that we really need to know where every asset is. So that common situation platform is really critical. We want to make sure where the ground troops are, where the different aircraft are, where the fighting basically trucks are, and all the equipment is, so that we can, if changes need to be done because of changes in the wind and any other things, we can quickly send the messages or coordinate with them. So getting the right information at the right time to the right decision makers, as well as the actors in the entire ecosystem is really critical. So we realize that the key is to bringing all that information in and make sure that it is presented or provided so that the decisions can be made on those. So that's one area. Second is the timely access to the information. One of the key areas there is, when does that information stale, when it is still valid. So a lot of times the forecast is used and things have changed, or we had sensor measurements, but those are still the same, or sometimes they have changed very quickly. So understanding that which information is the most current or which information is still valid is critical in making those decisions. So the timely access to that information and its relevance is another area that was brought up, which is somewhat related to common situation awareness as well. Then there's standards and common operating picture for interagency collaboration. There are multiple agencies involved, as you all know. When the mega fires happen, particularly when the fire grows more than 10 acres, at that time the coordination becomes very important. As in order for us to collaborate and coordinate, there needs to be standards. So for example, communication platforms, sending data formats, and all of those things, or just a voice communication. And many times, those things are evolved as part of the operating paradigm and practices, but creating those standards as we move forward towards highly complex fires, as well as faster response cycles and more technology as we brought together. We need to make sure that the things talk to each other, the artifacts talk to each other, so that we don't get into a situation where we send in messages, but those are not read by other parties and so on and so forth. So it's really important to figure out where the standards are needed, where the flexibility is needed, where the standards are needed, so that we're compatible with each other's operations. In the safety demonstrator series itself, we would be looking at scenarios that will enhance the situation awareness, time critical decision makings, and what amount of time it takes to make those decisions, commonalities and standards, standard operating practices, as well as the environment itself. If we don't have good communication, good navigation, GPS, for example, or surveillance systems, what's the best way to organize that? How much buffer we need among aircraft, and how do you support these operations so that the entire mission safety is guaranteed or assured. So some demonstration scenarios is crewed, uncrewed aerial operations operating in the same time, same place for surveillance and suppression, and extended attack through from the intruder. Sometimes we've seen the examples where the drones that are not wanted show up, and then how do you detect them? What do you do about them? And things like that. There could be other aircraft as well. So figuring out that whole operating paradigm when to maintain the safety of operations, reducing the controlled, basically operations, and then our we have a system called ground avoidance control system that has been used by F-15 pilots. It has saved 11 lives. So NASA's safety project has actually culminated into a significant technology that's been already used, and that will be another area where we could suggest opportunities so that we can improve the safety of these operations. And loss of control is another area that we have done significant research in the past that we will continue to support that and explore what opportunities for these operations as well. I'll stop here, and I think Natasha and someone are in the audience. They can also add more things, and please feel free to contact Natasha and Summer at the emails listed there. You can look at the workshop report and the website that's mentioned there, and feel free to contact me as well if you have any questions or comments. But this was a really a great effort, and thank you all for those who participated and those who are interested in this topic.
Great, thanks, PK. And as was mentioned in David Green's presentation earlier in the day, the aeronautics side of NASA's house, Aeronautics Missions Directorate, Research Missions Directorate, is an important component of our overall NASA approach to partnering with the fire community and increasing their capabilities and decreasing their or increasing their safety margin factors in collecting and supporting information on wildfires. And so the aeronautics component of NASA makes a large contribution to these efforts by looking at airspace integration issues with crewed and uncrewed aircraft operating in the same airspace, also in deconflicting that airspace, also in new platform designs and characteristics, and then how to increase the safety margin for safety margins for our wildland fire fighting crews. And so they're an integral component, and we'll be partnering with them, obviously, across our mission directorates for the next several years. And great to see that advances are being made as far as the workshop. Results are coming out now, and as PK suggested, you can gather the further information from the websites that are located on the presentation that he had, which are located in the NIROPS folder right now that Everett has shown us at the beginning of the meeting. So I don't see any real questions for PK, so we'll move on to the next speaker. Thank you, PK. As Everett says, great presentation. So thanks again, PK and the team from Aeronautics. And our next speaker is Vanessa Escobar from NOAA. I'm speaking to NOAA's Pathfinder Fire Tabletop Exercise. And Vanessa, why don't we do a sound check? Make sure you're there.
No problem. Can you hear me okay?
Yeah, perfect.
Great. Okay.
So let you take it over. Go ahead.
All right, Vince, thank you very much. And thank you, Everett and everyone else who got me connected here. What I'm going to be talking about, I hope starts to pull together a lot of the common areas that we've been addressing through engagement and tools. And what I'm presenting on for this particular tabletop is an event that we hosted last month. And we can go ahead to the next slide. This event and everything in my presentation really sits within the fire initiative that we have at NOAA. I'm not going to get into the fire initiative. I'm purposely going to get into the activity and the user engagement. And so I lead user engagement for NESDIS. I originally started leading user engagement for the geostationary future mission of GeoXO, the extended observations. And I quickly moved over to headquarters to develop a framework that will allow us to engage users in such a way that like we're hearing, we're pulling in the feedback, we're looking at what's actionable. We're also looking at partners and boundaries and understanding where within NOAA's capabilities and mandates can we look at really addressing user needs and providing solutions, or where is it that we really need to be listening and collaborating with others for, for providing future observations and data to the fire community across the different topics of fire. So thank you, David. I appreciate everyone, whoever is in this audience that did attend the tabletop. I think we've all attended several meetings together, so I appreciate the support there. We've had CAL FIRE and others. And so what I was saying with NESDIS and with our fire initiative, couched within our user engagement is something called the NOAA Pathfinder Initiative. This initiative is really very similar to the NASA Early Adopter Program in such a way. While I was over at NASA and worked with early adopters, we found that it was enormously useful to find people in society, people on the ground, boots on the ground, that can demonstrate how information is being used. So looking at early adopters and trying to bridge continuity of observations from NASA over to NOAA and look at the long-term operational needs and impacts, we stood up the NOAA Pathfinder Initiative, not only to serve as a bridge for continuity of observations and the understanding of how early adopters from NASA are going to be making decisions with follow-on missions, but also to be able to develop value chains and be able to demonstrate the return on investment for NOAA's operational data. And so one of the purposes and goals that the NOAA Pathfinder Initiative has is to demonstrate that ROI and is to provide and develop value chains across different thematic areas. I do have some animations, Vince. I'm sorry. If you hit next, it just notes that Y-Fire, which has been mentioned already here a couple of times, is one of our pathfinders for the NOAA Pathfinder Initiative. If you go to the next chain and, or excuse me, the next slide, you will see a series, and Vince, you can just click 3 times. I apologize to make you drive my animations. But what you're going to see here is a rather busy and complex image that really looks at the areas of impact. And if you start on the far right, what our Pathfinder effort does and what user engagement does at NESDIS is it looks at areas of impact and it provides traceability from the area of impact all the way to the instrument. NASA calls this science traceability. We call it value chains, user chains. There's several ways to look at this, but the point is to look at where decisions are made, what impacts are made by the use of products and observations, and understand how we establish value through that process. And so if you go to the next slide, you can see that through the Pathfinder Initiative, we develop a value chain for our Y-Fire effort. And what you see here is specifically geared towards geostationary data, the follow-on to our GOES-R series, which is going to be GeoXO, and what GeoXO will be providing in the future in terms of our observations. Now, in 2020, we started our user engagement with GeoXO, and over a series of workshops, we did collect enough data that helped inform the selection of our geostationary feature instruments. And one of the user needs that was very well heard was the need for improvement in spectral resolution. And so the ABI instrument for GeoXO is going to have an improved resolution from 2 to 1 kilometer. And what that's going to provide is going to vary. And we wanted to understand, what will that provide to fire? How will that impact decisions? What does that mean for products? What does that mean for the intake of this future ABI observations into existing systems? Rather than wait until that data are ready, we went ahead and started working with that now. And so through our Pathfinder Initiative, through a lot of work with Y-Fire, Mike Pavlonis over at NOAA, Dan Lindsay from the GeoXO mission, and others within NESDIS, We developed a synthetic product, what GeoXO will look like in the future, which you see at the bottom, and what the current GOES 17 ABI data looks like now. We went ahead and developed a scenario that would substitute the current data and put in a futuristic synthetic product. And then we just ran through a historical event and talked about what do decisions and impacts look like, and what are some challenges that people currently have, and how can we look at this one piece at a time? And it really is a process of eating an elephant. So if we go to the next slide, the fire tabletop exercise itself did have some very key objectives. We have fantastic relationships across many stakeholder agencies, but we wanted to bring them together in the context of geostationary data and the improvement of ABI. We wanted to look at how the efforts within our user community and how the satellite observations were going to be used, what the feedback was going to be with this early look at GeoXO's improved ABI. And we needed to understand, once again, the decisions that were going to be made, how resources might the use of resources might change based on the improved information. And we wanted to look at the tools and the capabilities that were currently in place with our existing Pathfinder, and also leverage the Pathfinder's relationship and their network, so we can see how the information is going to be distributed all the way from the instrument down to the people on the ground. Next slide, please. Now, this is a quick look at the agenda, and I have significantly more slides than I can cover in 15 minutes. So as I scroll through, the purpose is really to talk to you about the event and the way it's set up. And my hope is, through this particular group, to look at future tabletops and leverage the feedback that we're getting from the community and start exercising, some of these common needs for tools and products and integration through similar user engagement efforts at NOAA. And so if we go to the next slide, you can see who our partners were for the tabletop. For those of you that may not know, a tabletop in the context of this presentation and conversation is similar to a military-run tabletop. Being a 14-year veteran from emergency ops centers, we did a very similar lift and shift to what the EOCs run for tabletops, and that's essentially a simulation of a real-world event, and the substitution of one particular variable. This variable, as stated, is the ABI fire product, and we then replaced we replaced the fire detection product for a specific fire from 2020. That's the Bobcat fire. We picked that not only based on the fact that it had a huge impact for the community, but also because of the observations that were available and what the Wi-Fi Pathfinder used in response during that particular event. So it was a coordination of what is the right event for us to use in order to really start looking at the decisions and the needs and the actions, and start teasing out what we can do in preparation, whether that be training or delivery mechanisms for future observations. If you can go to the next slide, please, Vince. Now, the scenario itself, again, the second largest fire in LA, in LA County, being the Bobcat fire, and having burned over 180 square miles. I think for this group, I don't need to revisit the statistics on the fire, but again, there were several elements that made this event very usable and favorable for a tabletop exercise, where we can take a variable and replace it with the synthetic data. If you go to the next slide, something that we did in preparation for this was not just talk to Wi-Fi and understand the relationships and how information gets distributed from Wi-Fi and their system, but we needed to understand their intelligence real-time system and how they integrate information through their models, what they do, and who they partner with. And so this was a heavy component within the preparation and the discussion for the tabletop, because as we've heard several times, it's not the observation, it's not the remote sensing, it's not the product, it's really the integration of the systems and how everything is working together. So the key, once again, for the tabletop, how is information flowing? Where are some choking points? Is it a funding mechanism? Is it a resources issue? Is it a bandwidth issue? There are several things that are outside of our control that we also have to be sensitive to our fire community. And so as we prepared this tabletop, we really looked to identify, areas that provided a clear path forward, and some that, we really had to just be aware of and said, this is going to take some time, and we have to figure out, how to work through these challenges together. Next slide, please. Now, in terms of some high-level findings, I pulled them together just in a quick table for everyone to be able to see. But what our users, what our community, what the tabletop was able to provide was really looking at the specific applications and what we could respond to with satellite data, and sometimes the nature of the fire or the ecosystem of fire itself being so aggressive that you really needed to rely on observations. But that also had a threshold, and so it had a threshold in terms of timeliness, and we really needed to be sensitive to when is it appropriate, how quickly can you get it, and the geostationary data obviously being real time lent itself to that. We also stopped looking at seasonality and started looking at the year-round mindset, and I've heard it from several people in this workshop so far, how it's living with fire and being able to prepare year-round. So looking at the preparedness, looking at the planning, as well as the detection and the response. Now, if you click 2 times, I'll start getting into some of the modules. What we did for the tabletop was we broke up the event itself into 4 particular modules. This one was the pre-season planning. And the pre-season planning, again, looking at the year-round conditions and the activity that we needed to look at in terms of support and the type of information that would lend itself to those particular areas, and how the integration of data with wildfire was very important for making quick decisions. One element that we were very interested in looking at was lightning. And we realized that even though lightning data does have high demands, there were times where users were not applying lightning data, not necessarily because it was cloud to cloud, sometimes just because of integration and time to integrate. So we needed to be very sensitive to the type of information that was being integrated, but also to the information that people want to integrate and either don't have the time or the resources to do it. And every organization is going to be different. And Wi-Fi being very sophisticated and able to do much of their own modeling really opened our eyes to what they hear and what some challenges are. If we go to the next slide, you go into module 2. And being sensitive to time, just really high-level captions for, the information and using Wi-Fi to disseminate information to help local responders across 3 elements was really something that was very heavily discussed and revealed in the ignition and detection module for this particular exercise. And really, it's key questions. It's the 3 main questions of, is there a fire? If so, where is it, and what resources are needed? And this is where that improved spatial resolution of ABI and that fire product helped, and the substitution and discussion of how would resources change if we were to have that improved resolution. How much more quickly can you get there? That information obviously lending itself to saving money on resources all the way to saving lives. So we did spend some time on this ignition and detection scenario. We're still going through the data, so I do expect to have results to share with you the next time we speak. But it's again, this module here was really useful in being able to understand how and why that improved resolution in the fire detection product was going to be considered valuable for this group and for Wi-Fi. As we move to module 3 on the next slide, we looked at the growth and acceleration of the Bobcat fire, looking at the challenges and figuring out, the right mix of resources and communications and how we would be able to properly mitigate a fire without accurate data. And so redundancy came into discussion for this one. As we moved to module 4 and looked at the after action scenarios, we discussed quite a bit on the difficulty to prioritize the different aspects of wildfire and the full circle approach. I've heard in other presentations, that need to integrate the feedback. And I know oftentimes we're collecting feedback, but actual integration and not just the integrating, but getting back to the user as to whether or not it has been integrated, why or why not in terms of integration. Sometimes we as federal organizations have our own limitations as to whether or not we can integrate particular feedback. And we have found this to be very useful from the beginning of the user engagement, where we collected a lot of the user needs from fire, and we were able to integrate that need for improved spatial resolution with the selection of instruments for GeoXO, but not others based on budget and timeliness and technology. So the feedback loop here obviously being critical. Now, in terms of the takeaways, if you hit one more time, Vince, the key takeaway here is really the establishing of a universal data standards across agencies. Now, through the FIRE initiative, in a later slide, you will see that we do have several of the organizations here in this meeting looking at that standard across the agencies, trying to figure out, how do we coordinate communication, meetings, data, products, services, and information. And it's not to say that it's a one-stop shop, but we do need to coordinate across all of our agencies because it's the information that's valuable, not the source of the information. Next slide, in terms of our expectations and just how we're going to be providing that customer service. And one more slide over, it's the short-term focus on capturing and reporting these quantitative results across NASA, NOAA, and US Forest Service. So what we're doing through the initiative and through these exercises is trying to merge all of our information. If you go ahead and go to the next slide, you can see the context for our FIRE initiative. And last slide, you can go ahead and just capture my email and our Pathfinder. Jessica walked through WiFire. I do recognize we're out of time. It is a little thick of a topic, but I will be more than happy to address any questions with respect to a tabletop or how we're trying to work across our agencies in terms of these exercises and user engagement.
Thanks very much, Vanessa.
Sure.
Very good summation of the workshop, the tabletop exercise, I should say. I don't really see any questions in the chat. Oh, wait, there's one. Everybody has mentioned that it was a great presentation, David Green on down. And Vanessa, I see one question from Sean Nolan.
Yes.
It says, great briefing. How do we get access to the AAR of the TTX and how many participants? Thanks.
So I can go ahead, I can share everything with you on the AAR, details on the TTX. We actually have the entire thing transcribed. So Sean, if it's not too much to ask, if you can shoot me an email, I can share it with you. We will have it available on the GeoXO website, and I'm trying to move it over to the NESDIS front page as well. So I will have a number of products available, but just shoot me a note. I'll put my email in the chat box and I'll send it over to you.
And for our community, our TFRSAC community, we can also relay information for you, Vanessa. So if you send it to Everett and myself, we'll have access to that.
Absolutely.
List, which is almost 500 people on it now. So.
Oh, perfect. Well, that's the answer there.
Us too. Okay, cool.
Thank you.
All right, with that, I think we're ready to move on to our final presentation of this block before we take a break. And that is Win Idle will be presenting on the thermal working group updates over the last year. And I see you've got the first slide up there that identifies the thermal working group and its relationship to the TFRSAC and the wildfire remote sensing data requirements community. So with that, Win, you want to do a sound check for me?
Absolutely. Do you hear me okay?
Yeah, no problem at all. So I'll let you take it away. Thanks.
Great, thanks so much. So thank you, everybody. Appreciate the time. For starters, just wanted to give you a refresher that the Thermal Working Group is a multi-agency coordinating body. We're focused on advancing and enabling the development and delivery of data and products that basically come from remote sensing platform. And we want to get this out to civil users, give them improved situation awareness. And today, obviously, our primary focus is supporting the wildfire community. In briefings I've given over the past 6 months, past several years, but especially over the last 6 months, I've been told multiple times from different folks in DC that the president's administration sees wildfires as an absolute national security threat. So I think it makes sense that we obviously have this focus for the Thermal Working Group. So what we're doing is processing data from remote sensing systems and then making it available to National Guardsmen that we call the Fire Guard teams, have one in California, one in Colorado. They then analyze this data and disseminate alerts and updates to wildfire dispatchers, incident commanders, and others throughout the wildfire fighting community. The Thermal Working Group itself, I don't have the slide in front of me, but I assume whatever it has shows that our organization, I know Erica Kearns, our co-chair, is on the line. I'm the business ops manager from NGA. And then Everett Hinckley, our TFRSAC co-chair, is our other co-chair from the Forest Service. And primary customer as far as disseminating that data for operations throughout the country is Sean Triplett from the National Interagency Fire Center. We also work with the National Air and Space Intelligence Center, obviously our two guard elements in Colorado and California. USGS, they serve as our lead federal agency. They authorize the release of this data through the Civil Applications Committee. And we also deal at the state level with organizations such as CAL FIRE with Phil Salig, who briefed previously, Colorado Division of Fire Prevention and Control. We work closely with them with their multi-mission aircraft for cross coordination, and several other organizations. So looking back a bit, the Thermal Working Group in 2021 finished off supporting the first full year of providing nationwide wildfire detection, monitoring, and alerting all the way from Alaska down to Florida. The Deputy Secretary of Defense approved nationwide 24/7 capability for us through the Guard back in August of 2021, and then he extended it, or I should say, excuse me, she extended it once again in August of 2021 to go through the end of this fiscal year, 2022. So yeah, through September. Then this past December, on the 15th of December, when the president signed the National Defense Authorization Act, it directed the Secretary of Defense to continue using the National Guard to execute the Fire Guard mission through September of 2026. And obviously this was a huge success for us. We're really excited about that. Admittedly, when that happened, we were hoping that as part of that, there'd be a follow-on plus up in the omnibus spending bill that came out in March. We're hoping that it would include funding for the operators recognized for a nationwide program. Today, 24/7, we have a total footprint, a total team in Colorado of 16 analysts, and in California, 24. So 40 analysts that as a whole put people in the seats to work 24/7. So we were hoping that the omnibus would at least help pay for that, but that didn't happen. So have to appreciate what the Forest Service is doing. They're basically pulling money out of their suppression budget to pay for these operators, these analysts, year after year. So we on the Thermal Working Group are continuing to champion finding a way to fund them from another source so that they don't have to do that. So we continue to use the two teams with the Colorado analysts covering 5 of the 10 GACs. They've got the Rocky Mountain, Great Basin, Southwest, Southern, and Eastern, and then California has the others: Alaska, Northwest, Northern, and Southern Cal, and the Northern Rockies. And through 2021, which obviously we're calling fire years now, not seasons, They were kept very busy analyzing these fires, creating shape files, disseminating alerts to the Forest Service. They put those on the Enterprise Geospatial Portal that the GACs and incident commanders and first responders have access to analyze the data that we're putting out. And to give you an appreciation with this 24/7 nationwide, in 2021, the FireGuard teams reported on a total of 1,577 wildfires and disseminated just shy of 25,000 polygons, all hand-drawn. If you included the prescribed burns, that number would go up, but still pretty impressive to have numbers that high. So in line with our CONOPS, concept of operations of the twigs fire detection and monitoring, the FireGuard is authorized to disseminate alerts and updates as quickly as every 10 minutes. And that can be very, very helpful to the GACs, dispatchers, et cetera, if your fire monitoring aircraft happen to be grounded due to high winds. And I'll mention that, an example of that in a minute. It also is good that we're continuing to try and improve on the system's performance. We've got 24/7 engineering call-in in multiple geographic areas that helps us resolve outages. And it's obviously very important because we want to ensure continued confidence of the people that are serving these reports. We're excited this year in 2022 also that we're working on several capability improvements with the goal of enabling our FireGuard analysts to report on wildfires faster and with more confidence and accuracy. Been working with multiple agencies, including NASIC, Space Systems Command, USGS, and others on ways we can improve this confidence as far as the data we receive and get it out from multiple data sources. We're also looking at bringing in additional data sources that'll give us opportunities for better cross-correlation. We're also looking at ways to improve the robustness and sustainment of our operational systems. As I mentioned before, we've got 24/7 call-in, but we're also adding new hardware, new comm networks, so we can have a primary and a backup, for example, if one goes down, we have the other. And we're also excited to, I think as of this week, we're getting a couple trained collaborators on contract with deep experience in supporting both the intelligence community and the DoD military side to help communicate from our analysts through the intel community, the wildfire fighting community, with different chat services and by other means, just to improve communication. So with all that, I wanted to give you one anecdote. I'm pretty sure everybody on this call is very familiar with the Marshall Fire that we had just north of where we work at Buckley, up in Boulder County, that ripped through Superior back on the 30th of December. At that time, the Colorado Division of Fire Prevention and Control had serious problems with trying to gain situation awareness. Their multi-mission aircraft for fire monitoring could not get airborne. The winds here were over 100 miles an hour. And with that, the visibility on the ground was extremely limited. If you've seen the news articles that showed, for example, people coming out of the Walmart, I mean, it looked like they couldn't see at times more than 5 feet in front of them, just based on blowing dust and dirt and smoke. So with that, FireGuard was the only source, the only actionable above ground information provided to the incident commanders for situation awareness and for decision making. And based at least in part on that FireGuard data, the first responders over a period of time evacuated over 35,000 people. Sadly, 2 of them died, but when you talk to the folks that were involved, that is a minor miracle when you consider you're evacuating hospitals, the infirm, the elderly, and out of over 35,000 people, you lose 2. That is considered a very low number. And then after the fact, the director of Colorado DFPC, Mike Morgan, said, and I quote, "Without the information that FireGuard was providing, situation awareness at all levels would have been significantly degraded," unquote. And he commented afterwards, said that 2 deaths would likely have been significantly higher. Who knows where it would have been, but obviously grateful for the support that the FireGuard teams provided. So with that, the Thermal Working Group is really excited to continue this wildfire detection and reporting program now through September, at least through September of 2026, with the NDAA's direction and the President's signature, with the focus of contributing data and analysis to help this community's efforts to save lives, property, and critical infrastructure. And we're also, as I mentioned, excited to be developing and, when ready, integrating new capabilities to make next year's system even more improved and more capable. And that's all I have for today. I just wanted to thank everybody for your time and really appreciate it.
Hey,
Thanks.
Vince.
Yeah, great.
Yeah, if I can jump in here real quick. Yeah, I wanted to thank Win for being online today. It was a little bit, he had some things he had to deal with at his end, so we adjusted the schedule to make sure that he could get on. And I really want to thank Win and Erica Kearns and the folks all the people that support the Thermal Working Group. Sean Triplett's been a major player with that group. And there's a lot of people working behind the scenes there that have worked to develop these capabilities, to make them operational. There's a lot of hoops that you have to jump through on the classified side to get something approved, and find that middle ground where you have a capability that's beneficial to someone and provides useful outputs that can be used. And I think Firefly FireGuard is a perfect example of what can be done. Leveraging existing data and using it for benefit outside the DoDIC community, and figuring out how to get unclassified products over the wall. That's always a challenge. So as high as the challenges are on the unclassified side, they're even higher on the classified side. So I just want to make note of all the people that have supported the Thermal Working Group that work as analysts, and the policy folks, to make sure that this all came together. Because as Wynn said, for the Marshall Fire, that was a perfect instance of not having any other capabilities that we could turn to, but having this that significantly improved the intel while the fire was in progress. So with that, I'll turn it back to you, Vince.
Just have one question there in the chat from Deepak, and I can let Win speak to that provision of the answer if there is one available. And that's, who is the best single point of contact for FireGuard operation and future improvements?
Everett, who do you think? Should I say myself or Sean Triplett, or should we say one of the FireGuard? I don't know, the NCOIC Chief Warrant Officer Chris Kaus.
I think I would prefer to have things come through either you or me to the folks at FireGuard.
Sure.
But yeah, we can certainly field a request for information and do it in a meaningful way.
So Dee, as an answer to that, contact Everett and Win, and I think we have Win's contact information, or Win, if you can add it to the chat, that'd be perfect.
Okay, can do. Great,
thank you. All right, we're on a break period now. We went a little over on this session, but no big deal. As Everett said, we've extended the breaks to make use of that time available in the breaks for overflow if we needed it. Our next session, block 3, will be starting at 15:15 East Coast time, so 3:15, and that gives us about a 20-minute break. Is that sufficient, Everett, or do you want to extend it?
I think that'll work. That'll help keep us on schedule and give people a chance to get up and stretch their legs, get a bite, whatever they need, and then we can get back on track at 3:15 Eastern.
Okay, 3:15 Eastern it is. Come back online a minute or so before that, and I believe Birgit Peterson is going to chair that session, that block 3 session, and we'll see you all then. Thanks, everybody.